We are live. We are live with already nearly 30 people in, which is pretty awesome, actually. I was actually a bit worried about whether this stream would actually take place tonight, simply because they've got rid of Legacy. So I always used to set the stream up using the Legacy format, and then I had to navigate my way around Studio, which I hadn't done before. So that was a bit worrying whether or not I'd even get a stream up tonight, but it looks to be going fine. So I'm just going to do a few shout outs to some people in. And I did give a couple of wrenches out as well in the pre-show, which would have been to Matrix Media and Stone Monkey. So both of them got a wrench. Right, Han, nice to see you in. Excellent question you asked last night. As you know, we had Professor Phil Bell in, and he couldn't answer that question. You tied him up in knots. Excellent stuff. Amanda Young, nice to see you in. Cleary, Brandon Toy, nice to see you in. Martin Leakby, can you message me to let me know if you are the real Martin Leakby? Because unfortunately, we don't have that option to check your channel. So if it's the real Martin Leakby, I would love to give you a wrench. Who else do we have in? We have Seek and Find, Leeds Rules, Anthony Burrows, SE. I wonder what that stands for. Sun Wow, nice to see you in. Martin Leakby, hiya. Yeah, let us know if you're the real one. And Sean Hawkins. Right, okay, so we are joined this evening by Rude Earther. Let me just see if I can get you on. There we go. Rude, are you in the house?
No, it's Pete. I don't know where Rude is. I'm going to talk about Arse the Chorus tonight. I don't know if anybody's heard me talking about it before. Good evening, everybody.
Well, I mean, I don't know if you know, but last night when I finished the show, because you two were going head to head, battling like maniacs for about an hour.
It was crazy.
And so, I slyly ended the stream without you guys knowing. And then I kept on recording, and I sat up with you guys for about another hour and a half. You were still battling each other. It was so funny. And then eventually he left. Pete eventually left. He down tools. He had enough. It was time for him to go to bed.
We all got tired, didn't we? He didn't give up though. He kept his sleeves rolled up, mate. We kept punching each other in the face all night.
Well, it was weird. It was like it slowed down and it slowed down and it slowed down, and I thought, right, they're getting, they've got it all off the chest, and now they're going to be all right with each other, and then it just flared up again.
No,
and then
that's catching breath between rounds.
And it was like, I'm going to come round your house and sort you out, but I'm bigger than you. I've got a bigger chest. Oh, it was so funny.
Funny.
Mano on mano, or whatever it would be called. It was funny though. Right, so tonight we have, it's titled Open Panel, Open Topic Evening, and indeed it is. So we can have a chat about anything, basically. If there's anybody in the chat that wants to just join the show, you can call me on Skype. Search me, Ranty Flat Earth, dead easy to find me on Skype. Failing that, you can send me an email, ranty@rantyflatearth.com, and I'll send you a Skype link and bring you in. So, dead easy if you want to join. And of course, if you've already joined the show before, all you have to do is just give me a call on Skype and I'll bring you straight in. So, open panel, open topic. So if anybody's got any topics in the chat, we'll talk about too. But I did want to actually talk about this because this caught my interest. I just checked the BBC News, and I know how people hate talking about the BBC, but this really took my eye. Human trials for UK coronavirus vaccine this week. Ding, ding, ding. Human trials. What?
I won't be signing up for any of them. Did you see it just when it was all sort of breaking out? They were offering people to go and get infected, weren't they, for $3,500? Did you see that?
Yes. I tried to get Sleeping Warrior to join.
Did you? Well, to be honest, mate, I did ring him and I said, look, can I buy multiples? I want 10 goes. And he said no, so I just told him I wasn't interested in just the one. And I was looking to make a few quid out of it, to be honest.
Right. Okay. Well, to be honest, $3,500 in your pocket, I thought, well, I know Sleeping Warrior, we haven't spoken since, for what, 2.5 months or something, 2 months, 2.5 months. But, so it was within this time, so it was more recent. So I put a community post out, and I even tagged him in it, I linked him in it, and I said, you should go over there and sign up. It's just the flu. It's no worse than the flu. So you should just go over and get yourself £3.5 grand. I don't think he went. I genuinely don't think he went. I mean, you know, maybe he did. Who knows? But he hasn't been online for a week, has he?
Ooh, I don't know. Actually, he's not posted anything at all for a week.
I don't think so. I think he's gone on hiatus after he had to make another apology video. So there we go. These things happen. These things do happen.
What was the apology video regarding? I didn't see that.
Well, let's see if I can bring his channel. I've not watched the video. I've just seen the title of it. So let me just bring his channel up. Just bear one second. We also had a chat this morning as well. It was like we were chatting till, this is you and I, 2.5 hours we did. I should have recorded it.
Hey, something going on in the chat here. It's going off, Sean Hawkins. And right hand are lacing up here, lads. They're getting ready. They're wrapping the knuckles. They're getting ready to go off. Okay. Yeah, they ask him, when's it going live, man? Come on, lads, when's it going off?
What, are they having a fight, or is it for something else?
YouTube fight, innit?
Oh, right, okay.
Come on, man. Jeez.
Right.
We don't go that far, surely.
No, I don't see what it is. I see some money being floated around, $100.
Yeah, that's what I'm saying. It's going off. What's happening? I don't know what's happening.
Okay, so Sleeping Warrior put a video out. Let's have a look. So he put a video out a week ago. I was wrong. I did not prove moonlight to be cold on this occasion.
Ooh.
Okay.
Well, I saw the moonlight video.
Well, that's his video. That was a week ago. Community 6 days ago. So yeah, he's not been around for a while. Maybe he has gone and got that trial £3.5 grand. Who knows? Who knows? Delmax says it was a really fantastic show last night. Thank you very much. Sean Hawkins, if you want to join the panel, mate, and you and Right the Hand, you want to get on this right now, we can sort it out right now.
Go on, I'll stay quiet, I promise.
Yeah, think of that $100 of meth.
Oh, not all for weeks.
Like, you will be
around your house, like.
Oh man, be like Meth City. Come on, join the show. Go and win this $100.
In your house.
No, let's do it now. Let's do it. No, don't bring him in for next week. Get it sorted now. Next Wednesday.
I know, if you're in chat and you've got time to type words in chat, you've got time to speak them online, surely.
Yeah.
Jesus.
Here we go. Right, anyway, so there's another story I wanted to talk about as well, just highlight. It was this couple, they set off to travel around the world in this very small, what we can only say is a small yacht. Anyway, so nobody told us about the coronavirus pandemic. Can you imagine that? Setting off in...
Oh, is that them people who went to that little island and they didn't know anything about it?
Yeah.
Imagine that. Coming back, you think he was in a movie, wouldn't you? Going shopping and people have got frigging empty lollipop fucking buckets on the heads and that. You think, what's going on here, mate? Some guy wrapped up in bin bags with a brown paper bag on his head and one hole in it, like the Elephant Man.
Mason B says, yes, get Right the Hand on the show. Yeah, indeed. Who else? Come on. We can get this. We can get this. These guys, I mean, I want to see this. Whatever they're arguing about. Do you know what they're arguing about? I mean, I'll tell you what. Why doesn't Right the Hand...
I know there's $100 of meth involved, or maybe that was just... I think it started out as just $100, really. I think that's a bit of Chinese whispers, the meth part. But who knows?
Right the Hand, join the show and tell us what it is. Tell us what about... tell us what this disagreement is and what this $100 is for. I'd really like to know, actually, for real. It's just me being nosy, but I might be able to sort the argument out. I might be able to help you guys pick a winner here, you know?
Or at least provide the ring. You should change your name in the show to Ranty's Ring. No, maybe not.
No. Ranty's Ring, someone's going to make a sock of that now. You just know that's just going to happen. Oh, dear me. Right, okay, so we've got TheRumpus, I was speaking to Rumpus before. He said, if he comes on, you have to stop people like Brian, who constantly and systematically interrupt to the point that other people are unable to speak for more than 5 seconds. Okay, well, if we can agree to that, let him speak for more than 5 seconds. Yeah, I'm happy to bring Rumpus in. If you guys are up for that.
Speak. As long as he promises to not say the same word more than 3 times.
Mr. Gadget says, check your Skype. Okay, I'll check my Skype. Right, okay, Sean Hawkins, he thinks he can get me to admit that my belief in the heliocentric model is faith-based only.
Well, you've just said it, Sean, because you said it's your belief. Read that word,
man. We don't even need to go any further. You've just lost $100 there, Sean Hawkins. I'm sorry.
You're the bedroom guy.
You've literally just done it yourself. Oh dear me. Right the hand, mate. You've just won it.
What up?
You've just won it. He's just literally admitted it in his own question. He said, I asked him what the problem was, and Sean Hawkins says he thinks he can get me to admit that my belief in the heliocentric model is faith-based only. My belief.
Okay, well, there you go. That's good. There. But thanks, Randy. And he didn't even have to pay me. I was just like, look, we'll have a conversation, and at the end, if you admit, it's like, if I can't get you to admit its beliefs, I'll give you the $100. But looks like he admitted its beliefs, so
that's like setting up a trip, bro. Setting up a trip while you're walking 50 paces away from it and then running full tilt right through it, mate. Smashing your teeth off a rock. Well done.
I mean, that's in a screenshot, so like now all I'll have to do is just be like, okay, if it's your beliefs, how is that not faith? And then he'll just stutter around for a while, and then I'll be like, okay. The best part was he was like, oh, I'm not going to debate you unless it's on Jose's. I was like, bro, I'll do it on my channel, right? It'll be one-on-one in a Skype call. Like you'll have just as much airtime. I'll let you speak. But he's like, no, I don't. It's a joke.
Mr. Gadget says, check your Skype, but I did check the Skype and I don't have anything from you right now, so perhaps you should try and resend that. If
Sean wants the link. Sean wants the link. Alert.
Okay, Sean, add me on Skype, dead easy. Ranty Flat Earth, exactly how it's spelt, with capital R's, capital, F and E. So just find me on Skype, guy with the white t-shirt on, can't miss me. Or search for my email address, ranty at rantyflatearth.com on Skype. Add me, and I'll bring you right in. Dead easy.
You see his response to you, Ranty? Do you believe you have toes? No. I know I have toes. I fucking know it because I can see them at the bottom of my fucking body.
Mate, you can put socks on. You don't have to see them. You can wiggle them, motherfuckers, mate. You don't have to believe anything, mate. Some people can fucking write with the toes.
Let me know if you can wiggle the ball earth.
Oh, shit, man.
Okay, so
that's it.
I'm really interested in his take on this looming and how it begins right in front of your eyes. I was discussing this with somebody, and if looming starts right in front of your eyes, how do snipers shoot anyone? They're shooting ghosts, mate, aren't they? No one's ever going to get killed. He's shooting a loomed image, a ghost running along. So come on, let's get in it.
That's a good point. Like, Chemo does that a lot when he's talking about these people. He'll be like, all right, so you have this horizon and I'm looking at it, and if I shoot a bullet at it, what will happen? Will I hit water? Am I going to hit the target? And they're just like, wow.
That stuff happens in real life.
Yeah, bro, I've shot tons of guns, bro. The bullet drops first because it's a lead bullet in air. It's not dropping because of like the spin or the curve of the earth. And two, you have to be able to see something to hit it with a bullet. It can't be hidden behind a hill,
And every barrel's rifled in it, so you always get deviation towards the rifle in whichever way it is spinning.
Yeah.
It's normally clockwise the bullet comes out spinning, doesn't it?
That's just... These aren't arguments for the bowler. This is argument for it's common sense. If something is trapped in a long... They do. They think this is it. And they're, the bullet drops. The earth is curved. I'm like, are you fucking retarded? What do you think, a bullet would just keep going on a flat earth?
Well, this is the reality we live in, don't we? You wouldn't have gravity on a flat Earth. We'd all float off. So therefore, the Earth is a ball. You know, there's logic for you. Well, sadly,
So
it's not logical.
I'm just trying to get Sean in. Just 1 second, guys. Hopefully. There we go. Here we go.
Poor guy in trouble already.
You know, people, they've got someone in chat saying, like, flat Earth is a psyop to discredit truth seekers. Well, if that was the case, why would the system or any of its institutions create psyops that would put those institutions in question? You know, why would they do that?
Okay, so we're joined by Sean Hawkins.
Yep. All right, there, Sean. Yes.
Right, I posted a
I
posted a definition for the word belief in the side chat.
We don't. Okay, that's okay. Here, Sean. Yeah, I don't need definitions. Okay, because I can define what I see in the world with my words. Okay, there's no person that has like the monopoly on the definition of a word. So like if the dictionary came out and it was like a pear is an orange thing that grows from a citrus tree, you'd be like, well, the definition of pear is, you know, you'd be like, no, the fucking definition is wrong.
You're denying the definition of belief.
I'm saying belief is when you can't see or experience what you hold as true. So you believe.
No, belief is an acceptance that a statement is true or that something exists.
No, that's
it's not a statement of faith, man. It's
okay,
not.
Do you believe in the tooth fairy? Do you believe in the tooth fairy?
No.
Okay, so why not?
Because the tooth
right.
fairy.
So I've got the thing of belief.
Excuse me. Did you say you were going to cut out of here, man? Did you not say you were not going to interrupt, dude?
Oh, I just wanted to say this is the dictionary thing of belief, though. It's not what you said. It's an acceptance that something exists or is true, especially one without proof.
Your conversation.
Okay, Shawnee boy, don't go antsy.
But my belief in science, my belief in the heliocentric model is based on science and proven, demonstrable fact.
Okay, hold on. You just said a whole bunch. Hold on. I want to address a lot of those words. You said it's based on science. It's based on fact. Yeah. It's been proven. Yeah. Okay, hold on. There's only two things. You don't have 16 categories for what you know and believe. There's yes, it is true, and there is you believe it because you can't prove it. Now, I can take water and I can pour it on a round object and it will roll off of the object. I can demonstrate that. Now you can hold on, Sean.
That object and falling towards the gravitational pull of the Earth.
No, that's okay.
And it's gravitational well that it's in, dude.
Okay. So when you say gravitation,
example. That's a bad conflation.
No, it's a bad example. It's not a bad. There is no such thing as bad examples. Do you understand?
Well, the one you gave is
no. It's a bad example for your beliefs.
Or you're speaking from a place of dishonesty. One of the two.
I'm speaking of a place of observation.
So you think an experiment dealing with gravity would be valid done within the gravitational pull of another planet? You think that's valid?
No, I think when you look, when you say gravitational well, can you show me that? Can you quantify it? Quantify as real? Do it right now.
No, I can't.
Okay, so it's your belief then, right?
No.
Okay, so, bro, if you can't quantify it, then you believe it. I can quantify that a rock falls. I'll say, go outside, grab an object, and drop it. Here, listen.
There you go.
I can quantify that something falls. Now, you're going to say gravitational well. Quantify it.
No.
You can't.
Well is
gravitational well is your personal belief. So, will you admit that gravitational well is personal?
You're not going to let me speak, dude. I'm just going to hang up, okay? You're going to keep interrupting me like you do everybody. I'm just going to hang up, all right?
You never address the point.
I don't need this.
You don't need to address the point?
I'm not going to play your games, dude.
I'm not playing
My
games, Sean.
belief in science is not faith-based. You will never get me to say that.
Okay, hold on.
Right.
When
Okay.
I
So
drop
what's this? So what's the claim here? What's this bet about? Because I just want to be clear. We've got $100 on the line, yeah.
He's betting me that within 30 minutes he can have me saying
I didn't
that I have faith in science and faith alone.
I never gave a time frame, and I said that I will. You will admit that you have faith in the ball.
Man. I've got it screenshot. You most certainly did a half an hour.
Okay, well, if you just so here, Sean. First, we have to agree that reality is only what you observe. Agreed?
Well, yeah, to a point.
Yeah. Okay. Okay. So now we're on
France. I've never seen France, but I know it's real.
Oh, no. Hold on. So when you say I know France is real, when you can't use is France real and then reify, well, I've never been to France, so I don't know if it's real. I've never
know what the word reify means.
So don't question whether a place on Earth is real to demonstrate that water sticks to a ball. So if I pour water or if I drop an object in a vacuum and it hits the floor and you're going to say no orbits, you have to demonstrate these things. Now, when you bring up France,
demonstrate anything. All I have to do is
then it's a belief. If you can't demonstrate anything,
science, because science has already accomplished this.
Oh, and that's what a religion would say. They would a religion would say, hold on, Sean,
I can point you to proof that they've done.
What? Point you to the proof. What proof?
Been done, like Cavendish experiment, or other experiments like that. I can point you to those things, and you can look them up for yourself. They're repeatable. They're demonstrable. They're doable.
When you say Cavendish, all you're saying is, look, you can observe that these balls can hang from a string. Congratulations. Right. That doesn't prove the shape of the Earth. Hold on, Sean, you're in Earth. That doesn't prove the shape of the Earth unless you have a belief.
Oh, yeah, it does. It most certainly
does. No. Okay, so how come it doesn't prove it today?
We know that water has mass. We know that by the angles to Polaris, the Earth has curvature. That geometry
hold on. Slow down. Sean,
see, it's not just one thing, man.
Slow down. Sean.
Go together to prove the body of science.
Hang on, Sean. We're going to go one by one. Okay, now you say things by themselves don't prove anything. So when you say the angle to Polaris by itself, that doesn't prove anything, right?
One thing. No, you're misquoting. Okay. You're misstating me. You're misstating my position.
Okay,
so
clarify.
One thing proves the whole heliocentric model.
Okay, so we would say it's a collection of things that lead you to believe the Earth is a ball.
And the formulas and the math and the data that comprise the heliocentric model.
Okay.
When you say heliocentric model,
could I just clarify something here? So you mentioned before about France, and you said that other people would have been to France. You don't have to go there to know that France is there, or along those lines. Was that right?
No, I can find a map. I can find record of where people have been. Yes, I can look up and see that France exists.
Okay, so that would be so would that be taking somebody else's word for it?
Well, you have to do that with everything, but you do not take it on faith.
Okay.
I have a purple dinosaur in my bedroom. I would not believe what you say until you showed me and proved that you have a purple dinosaur in your bedroom.
Okay. And on that same vein, if you tell me that water can stick to a huge ball, I want to see that.
So my last point on that whole thing was I just typed into Google taking someone's word for it, and it's the first thing that pops up. Take someone's word for it. To believe what someone claims, especially without checking or verifying for oneself. That's the
right. I said I wouldn't take your word for it.
But you take other people's word.
No, if you take someone's word for it, you believe someone's claims. It's a belief.
I wouldn't take their word for it unless they had.
But you just said you did.
Unless they had proof.
But if you're taking somebody's word for it, you don't need proof. Because if you have proof, then you don't need to take their word for it. It's been proven. So you're contradicting yourself. So
semantic there, but I would not believe unless they had proof. Let me rephrase that.
Sean, can you demonstrate that the Earth is a ball, or do you believe that people's prediction? Okay, so how would you demonstrate it to me without your beliefs?
Hold on.
COVID.
No, I vape and I swallowed wrong when I exhale.
You're not supposed to drink it, dude. You're supposed to put it in a device and vaporize it, but whatever.
I do, but it's like, have you ever smoked a cigarette and like you cough when you exhale and it totally messes your lungs up or messes your throat up?
Anyway, how would you demonstrate this ball to me?
The angles
without your belief. Okay, that's not demonstrating a ball, Sean. That's you showing me some angles and your belief that the Earth is a ball to cause it.
The geometry of the angles to Polaris only works on a spherical object. It does not work.
It only works if you believe the Earth is a sphere. You're not demonstrating that the Earth is a sphere. You're demonstrating your belief.
It does not work on a flat Earth.
Math is a language, okay? So it works because it expresses verbally.
It's a language that describes stuff, and the language says it does not work on a flat Earth.
No.
I've proven this on my channel.
No, you can't. You don't prove anything, okay? Here with math. Okay, so let me ask you a math question.
Science does not.
So let me ask. Okay, so if I have one pile of sand and I add one pile of sand, so 1 plus 1 pile of sand plus 1 pile of sand equals how many piles of sand?
2 piles of sand?
No, I put them together.
Then a pile of sand.
So 1 plus 1. So you're saying 1 plus 1 equals 1.
Half a whole.
You just said 1 plus 1 equals 2, yet I just showed 1 plus 1 equals 1.
Right.
So how does math prove anything?
You're speaking in different terms.
No, so math just expresses verbally.
In a collective term, when you say I have 1 pile, you're talking about a grouping of grains of sand.
Oh, hold on, let me ask you this then. So is one, hold on.
Millions. That's millions of grains of sand.
Sean, is one an objective truth or is it a subjective description?
It depends on what you're talking about.
That's subjective description, That's subjective description, Sean.
Okay.
Okay, so one, if it's a subjective description, hold on, Sean, I'm making a point. Please let me finish. I'm making a point. If it's a subjective description and not an absolute truth, then it cannot prove anything. It's only describing the reality that does prove objectively, right?
Right. Sand is a subset.
Okay, right. You said right. I don't need any more.
One pile.
Stop.
A pile is not an objective thing. That's a subjective thing.
Stop.
Right?
Okay. No. Don't. You said right. Don't continue on when to deflect. So you've just agreed that one is not an objective truth, and it is a descriptive word to describe the actual reality, which is objective. That's why the word objective, the first part of it is object, because it refers to the object that
we're getting into your word.
You're interrupting. John, you're interrupting. Sean, you're interrupting.
All the time. Let's get back to the subject.
Sean, you're interrupting.
Do I have faith in science? No, I don't.
No. Science is a word.
Science is
a word.
It's a word.
Show me science in reality then.
Everything is a word.
In reality. Show me science in reality. Quantify science to me in reality.
Is that who you got? Sean Hawkins here? Is that Sean Hawkins? Oh no, sorry, man. Is it?
Yeah, I'm getting him to prove his faith in the ball.
This guy's been stalking me mad hard for so long. Over what are you stalking me over, dude? Polaris angles?
Yeah, no, we just shit on his Polaris angles.
Holy fuck! Is this guy? This guy's one of the biggest morons I've ever encountered in this movement.
And you're a liar.
Hold on, I got him on a point. Let me.
Demonstrable.
I got him on a point. Let me just finish. Let me finish the point I got him on.
For every 69 miles you move from north to south or south to north, the angle to Polaris is going to change by 1 degree. This is an undeniable.
You moron. Just take 360 degrees, take 24,901 and divide it by 360 degrees. You get a fucking, you're 1 degree, right? You're 69.169. Right there, Shawnee?
Absolutely.
Now, let me ask you a question. Sure. On a flat plane, when an object's in the air and I move from it, will the object appear to move down in degree and angle?
If you move on a flat surface.
Shut the fuck up and answer what I just said.
I am answering it. So you shut the fuck up. If I'm on a flat surface, if I move 69 miles, that will not change by 1 degree. It will change.
That wasn't my question. Listen to what I'm saying.
I just answered
if an object is in, listen, you little fuck. if an object's in the air and I move, and if I move from my position, will the angle change to the object?
Yes, the angle will change. But
there you go. Thank you very much. Now, do you account for that in your little fucking 69.169 miles? Do you account for the fact? Do you account for the fact that when you move away from an object, based on your angular vision to that object, the object will appear to move downward or upward, depending on how far or how close you move to the object? Do you account for that fact for vision?
Are you ready to let me speak?
Do you account for the fact that vision does it,
On
Sean?
a flat surface.
Do you account for vision is the reason why an object can move closer or higher an angle and lower an angle? Could you account for vision for it?
Account for vision. Vision makes up everything we see. We can't see without vision.
So when the angles move from you, are you accounting for the fact that it has to do with your angular position to it and nothing to do with the ball?
Are you going to let me answer?
Do you understand that your position into angle has to do with your vision to it and not a ball? Do you understand?
Stop
that it has nothing to do with the ball.
Let him answer.
On a flat surface, if you move 69 miles, the angle to Polaris or the sun or whatever you're looking at is not going to change by 1 degree. It is not going to change by the same amount as it would in real life.
Correct.
How do you know how a planet-sized flat plane would look and act
and behave?
Because
modeled it on paper. I've modeled it with
okay, hold on.
In 3 dimensions, you fucking moron.
Simple trigonometry tells you that.
Okay, hang on. Okay, so let me answer. Let me respond. So where did you get the basis? Like, because when you simulate, right, you have to take from reality. Hold on, Sean, you're just, let me speak. So when you simulate, you have to get, what you're doing is you're taking reality and then you're going, okay, reality behaves like this. Now let's transcribe that onto a computer. Now, where did you observe a planet?
Just so you guys know who's actually in, we have TheRumpus, we have Sean Hawkins, we have Right the Hand, and we also have Rude Earther.
Let me address that. Let me address that.
So,
hold on.
Flat Earth
Draw him a
data.
diagram to show him. Draw him a diagram.
Hold on. So what you're saying is that all of your simulations are not based on reality, but on a diagram that you drew.
No, they're
exactly.
My ones I drew are based on
what? Where is the basis for? Hold on. What I'm trying to get is where is the basis for how a planet-sized flat plane would behave, so you can then model it in a computer? Where do you get that information?
It conforms to trigonometry, you idiot.
No, trigonometry does not use physics or visualization or diffraction, whatever words you use.
Yes, it does.
Trigonometry is a word.
Yes, but it represents the mathematical procedure you can use to work out the angle.
So hold on.
Freedom's a word, but it's a word worth dying for. But I'm going to die for a word. That word's going to be
no freedom. You don't die for freedom. You die because you don't want to have people stop telling you what to do. Okay. Freedom is just okay, hold on. Before we go any further, Sean, do you agree that this world can be broken up into 2 things? The reality of objects and the words we use to describe it?
Sure.
Okay, so there's only those 2 things, right? There's the reality of the objects and the words we use to describe it. So now, when you say we have a model of Earth, right? Can you show me this in reality, or can you only tell me it with words?
On a flat Earth?
No. You said I have this heliocentric model. So now, is it something that you could show me physically, demonstration, or is it something that you tell me verbally?
I can show you in an app called Stellarium.
No, but okay, hold on. Now, what happens in an app what represents reality? So, like, if I said, so if I can fly, hold on, Sean.
You've asked
Sean, wait, no, Sean, talking, Sean. If I can fly in an app, can I fly in reality?
That makes no sense at all.
It could model you flying in reality.
But I'm asking if I can do something in an app, does that mean I can do it in reality?
No, but it can emulate it. You doing it in reality.
Let me ask a question. If you open Stellarium and you and you point it up at the night sky, is what you see, all those stars, where they're placed, in relation to each other going to match what you see on your phone? Yes or no?
Hold on. Stellarium is not reality.
Yes,
it's a program. So if I said, prove to me, hold on.
Yes or no?
No, I did answer it. It's a program and not, hold on, Sean.
It matches reality, you idiot. It makes predictions that are matched by reality. It matches reality.
It doesn't match. It's modeled after reality. So you watch, hold on.
It's modeled after the heliocentric model, dude.
What model? Your model is the observation.
Shut the fuck up and let me speak.
You gotta answer my question. And now you have Rumpus who's just talking and talking.
Stellarium was designed using the heliocentric model. It's in the source code.
No, it's not. It's designed using observations of reality. Hold on.
It matches reality.
Do you use hold on, Sean? Do you use hold on?
Dude.
Hold on.
No,
this is very important.
The source
you haven't stopped talking. You haven't stopped talking, Sean.
Model. If you shut the fuck up and listen, you might.
I'm addressing what you said. Does it address the heliocentric? Is Stellarium made from the heliocentric model, or is it made from observations in reality?
It's designed using the
that wasn't what I asked. I'm going to ask it again. Listen,
yes, it was. You asked if it was.
I don't say yes. It was
using heliocentric model. It is. It is.
Is it? Hold on. Is it made from the model or from observations of reality? Don't say yes. You need to pick one.
The heliocentric model is based on observations of reality.
That's not what I asked. That's not what I asked. Sean, listen. Sean, you're getting triggered. You're getting triggered. He's getting triggered. Uh-oh. His face is in question. Because you're not answering.
Listen, let him talk.
No, he's not answering. Sean.
He's allowed to talk. Let him talk.
No, let me talk.
You've been doing all the talking so far. He's barely spoken. You've been speaking about 80% of the time. Sean's only had about 20%. Let him talk.
Are you done?
Is Stellarium based on? Is Stellarium based on reality? No, you have to.
$100.
Sean. Sean, you're triggered, bro. You're triggered.
I'm out of here.
You're triggered. Is Stellarium based on reality or on a model? This is what happens.
Everyone seems to believe it. I have no idea why.
They believe. They believe, and then they get mad and they run. And that's the problem. He needs people like Rumpus to come in and overtalk the fact, because Rumpus has a job, and his job is to troll these areas and wait for somebody who is getting.
Who keeps kicking?
And then defend them.
Hang on, hold on.
Hold on, Ranty.
Who's kicking?
I'm not going to be in a ball with Rumpus, okay? Because I give you good content and Rumpus gives you garbage. So I'm kicking you because you're a piece of shit and you're ruining the fucking call. So I'm going to remove you until I'm done, and then I can get my words out, because Rumpus will just talk. That's his deal. His deal is to just nonstop talk so nobody else can get a word in. And he ended this conversation with Sean because he knew Sean was taking a nosedive and was going to say stupid shit for the ball. So he had to come in and save him. That's the job of the Rumpus. Okay, so I'm not going to let him do his job, because I can't waste my time with him just screaming over everybody. Like he's just a fucking absolute retard. But we can see how Sean just degraded. Okay, how he just degraded mentally when he tried to explain his model.
That's better.
Okay, I just want to shout out a new member. We have Windrider who joined. Thank you very much for joining. Right, Rumpus, do you think it's your job to come in and just, upset the apple cart, or do you come in to try and actually talk?
Well, I came to try and talk. I mean, I thought that the hand, whatever his name was, just making lots of abusive comments to Sean, and seemed to me that people needed to know what the reality of the situation was, and not just have some git just simply shout Sean down. So I was trying to make useful contributions.
Don't you think
he kept on kicking me?
Don't you think it was more that it was the crescendo of the conversation? The point was, it was right at that point where Sean just needed to make an answer, a proper answer, rather than gish galloping around stuff that kept this same question being repeated over and over and over.
Yeah, but he never allowed Sean to speak. He'd interrupt him about 3 seconds into his answer. And if you want to expose Sean, if you believe that Sean's not answering the question, then Oh, Sean, I didn't kick you. Sorry, John, I didn't mean to offend you. I was trying to support you here. I was just trying to stop you being shouted down. Sean's apparently upset with me for some reason. I don't quite know why. Where was I? Yeah, so I didn't like Right Hand just over talking Sean all the time. It was just, and you should have stopped them if you wanted Sean to get an answer. You had to allow him to have time to give an answer.
Well, to be honest, it was basically a 30-minute back and forth between Sean and, I mean, that was the challenge, right? Yeah, within 30 minutes. So me constantly interrupting isn't really going to achieve that. It's far better to let them bash it out between themselves for this 30 minutes. Let them have their
shouting match. Well, why didn't you just say to the Right Hand, you've got to let Sean answer, and then that wouldn't have stopped the debate. That would have helped it. Instead, all you had was just Right Hand shouting over him. It's just ridiculous.
I think he just wanted him to answer the question. He was given a specific question that just needed a very quick answer. It didn't need to be gish-galloped around the block.
He wasn't gish-galloping. He wasn't being allowed to speak. I've upset Sean, obviously. I was asked to come in, Sean, potentially into the conversation, and I did. And I didn't agree with what Right Hand was doing. That's all. So I'm sorry if you've upset you.
Sean says, Ranty, and I won his challenge. So I don't, I mean, was it 30 minutes? Was it 30 minutes? I don't know. It was close to 30 minutes. I wouldn't say it was quite 30 minutes, though. Maybe 20 minutes you two.
Well, Sean left of his own accord, didn't he? He didn't get kicked out, did he?
Yeah. Sean rage quit. So I think that's a forfeit, isn't it?
Yes, I mean the fact that Right Hand doesn't seem to understand that you can use trigonometry to work out how Polaris behaves, and he says, "How does this match?" In other words, he's saying you have to go and get
Polaris. Rumpus. How does Polaris behave? I'm going to take note. Please tell me how Polaris behaves.
Right, as you change your latitude by 16, change your latitude. If you follow a line of longitude, every 69 miles.
You're changing your latitude or your longitude. What are we doing?
If you let me just answer, I was clarifying it. Shut up.
Pick one.
Shut up.
Pick one.
I was saying it, and if you listen, you'd have got it. Right. So as you're following a line of longitude, which changes your latitude, so you're following a line of longitude for every 69 miles. You go along that line of longitude, changing your latitude, then the angle to Polaris relative to the horizon will change by 1 degree. That doesn't happen on a flat Earth. It only happens on a...
Hold on, Rumpus. It doesn't happen on a flat Earth. Great. So let me ask you a question.
It does.
Hold on. Let me ask you a question. What's the difference between a flat circle in the dimensions of 3,959 miles versus a ball of 3,959 mile radius? Can both a flat circle and a sphere have the same diameter and radius and circumference?
But it can't. Hold on. But we're talking about Polaris here. Sorry.
No. Just answer the question. Can a flat circle
I didn't understand
and a sphere?
Okay. Try again.
Can a flat circle and a sphere have the same circumference?
Yes.
Can it have the same diameter?
Yes.
So what is the proof that based on 69.169 miles every time I travel that distance, that it's not possible on a flat circle?
Because if you assume that Polaris is sitting at some fixed distance above the surface of the flat Earth, then you're going to get...
So hold on to clarify, if you assume it's at a fixed distance, So I have a question for you. The closest place to measure the angle to Polaris, just using basic trig, no presupposition here, I think the closest they can get to Polaris is 780 miles away. To the North Pole. Let me rephrase that, to the North Pole. Assuming that the North Pole and Polaris are relatively in the same zenith position, right?
Well, let's draw a diagram. Here we go.
No. I'm not. I don't want to do any orthographic there.
No one's ever been there.
Can you see the diagram?
So answer my question.
I'm going to draw a diagram that will clear up any confusion. The diagrams make things much, much clearer.
No, they don't.
Yes, they do.
Rumpus, you're full of shit. You've been busted so many times.
You're a moron.
Here's something I will do for you. Your orthographic bullshit. your orthographic bullshit. I will never indulge. I will never indulge your orthographic bullshit ever again.
You're an idiot.
The question is, can a circle and a sphere the same dimensions?
If you're denying,
can a circle and sphere have the same dimensions? You said they can. So if we took the 24,900 and circumference and divide it by 360, we can roughly get the same calculation, right?
Okay, right. Listen, guys, one at a time, please.
Right. So I'm going to give his answer. He's saying basically it's possible on a flat Earth. No, it isn't. So if you have up here, if you have Polaris up here, and let's suppose they seem to, I don't know where they think it is, well, I don't know how high they think it is. It's a fixed height. So the point is that if you then have an observer I've got here, and they move along here, then the angle, let's draw another line in just to do another one. The angle here, which we'll call A, and we call this one B, and if we have a distance here.
Yeah, we all know the angle will be different there, Rumpus.
Right. Okay. So the point is the angle there, the angle A, the tan of A, is equal to y over x, and the tan of B equal to, we'll call this x2. We'll call this x2, and this one x1. So the tan of B, I've got some bonus brackets there. Tan of B is equal y divided by x2, and this one is going to be x1. So that is not going to change linearly. So whereas on a sphere, this is a tan function, and that's not going to change linearly like it does on the Earth.
So let me ask you a question. Yes, okay, so here's something you have to do, Rumpus. When you're doing your calculations, please provide in the elevation of the observer. Because if you're going to take, shut the fuck up. Shut the fuck up. Shut the fuck up. I know you don't like being exposed as a stop interrupting me. Shut the fuck up and let me finish.
So, to be fair, Rumpus, you did a full presentation there. At least let him make a question.
Yeah, but he started swearing at me, so I wasn't going to tolerate that.
Shut up. So at the end of the day, your orthographic pictures do not tell reality.
They do.
Okay? No, they don't, sir.
Exactly.
They do not highlight. Reality. They do not highlight reality.
Exactly.
First of all, if you have two observers at different elevations, their angles will be different. Not just different distances to the so-called apparent position.
Yeah, but we're not dealing with that situation.
Exactly. So your orthographic drawing is nonsense because it negates elevation, perspective. Do you understand? And the apparent distance. The apparent distance. Now, listen, Rumpus, your drawing would be good in looking at a building. Your drawing would be good at looking at a building 60 feet away from it, 100 feet away from it.
You don't need.
This is what you're doing. You're using this basic orthographic level. You're using this basic orthographic drawing. You're going to interrupt me? You're going to just keep going, eh? You're showing basic trigonometry that's viable. What happens to when you do the angles at longer distances? The trigonometry starts to become incorrect. So listen, bud, over shorter distances, when you're doing your little orthographic drawing, okay, you're doing it where if an observer was standing 60 feet from a building looking up and measuring angles, those angles are accurate at that distance. What you're doing is you're hijacking the fact that flat earthers like to claim that the Polaris is close, and you're going to use that for your trigonometry, indicating apparent location, because you can do a couple of variables. You have to assume the position of Polaris, number one, is going to be your position in argument, which is a fallacy, number one. You're going to work out the angles however you want to prove what? That you can't measure? Of course you can't measure over long distances. You're not adding in refraction. You're not putting in perspective. You're not doing any of that. The reality is,
the angle
is objects in the air, if you measure them in the distance, if we took a tangible object and we put it 100 feet in the air and we measured its angle and we move from it and close, it will change, right? On that flat surface, it will change to degree, correct? But over a longer distance, like let's say we're 800 miles away from it, and we're looking at an apparent object in the sky, you could say it's 3,400 miles up. You could say it's 4,400 miles up. The angles will change. But here's the thing. you'll still get that 169 mile relatively that apparent change in degree. But that's also possible on the dimensions of a flat circle.
No, it's not.
Yes, it is. It can have the same. Yes, it is. It can have the same dimensions.
Not possible. I'm showing you why it's not possible, because the relationship is a tangential one where x and x2 here are the distance you move. Be quiet. You've had 5 minutes. Be quiet. You've had 5 minutes. Shut up.
Polaris pole.
Now I'm going to respond. On a flat Earth, the relationship between the distance x1 and x2 is a tangential relation, tan as in tan trigonometric function. On the spherical Earth, there is a different relationship, and it's linear. The angle to Polaris here relative to this straight line here will change linearly. That's a fundamental trigonometric relationship, which I can go into if you want me to, which means that the angle will change linearly with a linear change, where every 69 miles along this surface here, the angle to Polaris will change by a fixed degree. On the flat Earth model, it doesn't do that. It changes by a tangential relationship. Therefore, we can dismiss the flat Earth immediately.
Using a flat Earth model, no one has been 90 degrees below Polaris.
Exactly. Here's the thing. How close can you get to the North Pole? In reality, Rumpus, what's the closest we can get to it?
Right on it.
No one's been 90 degrees below.
I'm sorry. Sorry, there's no listen, dude. There's no picture of the North Pole from a zenith position looking up. There's none one of the South Pole either. These two photographs of these these two supposed positions in the world of the sphere, claiming the North Pole and the South Pole. There is not one looking upward zenith position of the Polaris star or the Southern Cross.
Well, obviously
there's no zenith position of them.
You can't see the Polaris. This is another proof of the fact that we live on a sphere. Is the fact you can't see Polaris below the equator, which we would be on this flat Earth.
Once again, you're forgetting objects.
You get a turn.
Objects.
You'll get a turn.
To move into the apparent junction of the human vision as it moves away.
I'm still in mid-sentence. On a flat Earth, you will be able to see Polaris wherever you were on the plane. The fact that you can't see it means you're not on a flat plane. Go ahead.
Yeah, bud. So you, as a human being, have a limited vision there, Peckerhead, and you're limited to the angle of how close you are to the ground. The closer you are to the ground, the more limited angle you have to how far you can see. So, because the horizon, which you've already admitted, once you were asked once already, which was, I'll ask you again, what causes the apparent junction of the sky and ground, Rumpus? Is it Earth curvature, or is it your eyesight?
Earth curvature, of course.
Okay, Earth curvature. Oh my God! When I asked you before, you said it was neither. And then you said it wasn't perspective, and now you're saying it's Earth curve.
You changed your answer, Rumpus.
So listen. Once again, if we are going to determine the position to anything in the sky, we have to first of all conclude what is causing the junction of the sky. You claim to be Earth curve.
Of course, this is reality. Yeah.
Can I jump in?
You're a moron, yeah.
Can I jump in and just ask Rumpus a question?
Okay.
In comparing the models, you're saying so a 6 foot high man at position B should see the whole of the flat Earth. So position B is going to be it's not even the equator, is it? That there.
Well,
so
it depends.
Let's pretend equator where the actual Polaris is at the horizon. Yeah. So you just said a minute ago, you should be able to see Polaris all over flat Earth.
Correct.
Now, can I ask a question? How can you expect that? Because the ISS at 250 miles up only sees 3% of the globe Earth.
Well, that's because it's a spherical Earth.
3% of it.
What?
Yeah, I mean, well, let's see. Okay, let me draw. If I put the ISS in here.
Yeah, I know what you're going to do. It's spherical distortion.
So here we go. If I put the ISS, so there's the.
But you're expecting
a 6 foot
let
me answer, Gleem. Let me answer. So here is the ISS. It's not actually. It's actually closer than that to the rest.
So did we get off? Did we get off?
I'm still answering. Shut up.
Apparent junction
Shut
of the
up.
sky and
I'm
ground.
still answering. Shut up. Right, so here to scale, well, not to scale, the ISS is probably about there. So when on the ISS you draw lines of what they can see to the horizon, I'm going to join the horizon line here. I'm going to put little lines where they can see their horizon. Oh no, be quiet. So they're only going to be able to see that little area there from that little star. That's all they're going to be able to
Rumpus,
see. And that's got
Rumpus,
nothing to do with
can you
this
see?
star.
Can you
hold on? I'm
Rumpus,
nearly there. Finish 5 seconds. The flat Earth diagram I've got here has got absolutely nothing to do with the ISS on a spherical Earth. Carry on.
do you think you can? Okay. Do you think you can see the Southern Cross from Florida and Texas?
Well, the Southern Cross isn't quite at the South Pole, so you might just be able to see it possibly.
So, what if you could see it from Texas and Florida, the Southern Cross? How would you feel about that?
Actually, it's quite a long way from the Southern Pole, isn't it? The Southern Cross is effectively, I think, something like over here. It's quite a long way from the and obviously, of course, it's
just wanted to know if you know you can see it. That's all. So you can see it. You're saying?
I think it's quite, because the Southern Cross is nowhere near the southern. It's actually I think it's a good 20 degrees off the thing, so you probably could see it. Don't know for a fact, but what is your
evidence? What is your evidence that the physical Earth curve is causing the apparent junction of the sky and ground? What is your evidence of that?
Well, we know that the Earth is curved. We know the Earth's a sphere, and we know that
I asked for evidence of that, not know what you know. Evidence of it.
Nearly finished, and the model we've got for the Earth exactly matches what you see in reality. So we know it's the Earth curve.
But the stars don't move at 69 miles per 1 degree.
What causes the apparent?
Hold on.
What causes the apparent junction?
You
said.
Hold on. I just want to respond to
you said a model proves it.
Let me just respond.
You said a model proves it.
Hold on, let me just respond to the other guy. I'll come back to you, right hand. So are you claiming then that if you go every 69 miles, you follow a line of longitude, that the Polaris does not dip by 1 degree? Are you claiming that? Whoever made that question.
No, I said that 69 miles per degree of rotation isn't fully proven, is it? Because there's optical observations showing that the stars slow down near the horizon.
Right, so are you accepting that for every 69 odd miles you go up a line of longitude, Polaris will dip by 1 degree?
Yeah, so that's a great...
off your horizon.
Yes, exactly.
So you're not disputing that?
Yeah.
Exactly. So what caused the horizon? You're saying physical Earth curve.
Can I just listen to him? Are you disputing that or not?
Listen, those degrees of geometry are based on your eyeball, and they come from the sextant. And that's what the grid is based on.
Telescope does the same thing. Telescope does the same thing. It's irrelevant.
It's a linear observation.
Right. So you do accept. Hold on. So you do accept that for every 69 miles you go north along a line of longitude, that Polaris will move up in the sky by 1 degree.
Which we established.
Listen to the other guy for a moment. Are you accepting that for every 69 miles you go up a line of longitude? Right, and that happens whether you're using your eye or using a telescope or using a camera. It's true for all of them. So your issues about refraction are utter bollocks.
But what you don't know how high Polaris is.
It's not bollocks.
No one's ever been 90 degrees below it, so you don't know if 90 degrees on the grid is actually true 90 degrees below Polaris in reality, mate. You only know what the grid tells you. That's it.
That's gibberish.
The grid is based on observations from the sextant.
No, you just said you accepted that for every 69 miles you go up a line of longitude.
On the man-made grid, yes, but not on the man-made grid.
Hold on, you either accept this or not. Do you accept that if you travel up a line of longitude going north, the Polaris...
Yes, based on the man-made grid system.
Well, hold on, you don't even base it. Just you can take a measurement yourself. You can
it's
take your
the datum points. He's right, Rumpus. He's right. It's based on the datum points. That's how we originally got the latitude line.
Based on anything. It's based on observation. Are you saying if you personally went out and then travelled up a line of longitude and took observations of Polaris relative to the horizon, it would or would not go up by 1 degree for every 69 miles you went north?
That's irrelevant because you don't know that.
You don't accept that. You don't accept that.
You don't know that 90 degrees zero below Polaris.
Hold on.
Where it is in reality.
Right, hold on. We still haven't sorted out whether you just accept this or not. So we're trying again.
Degree per 69 miles. Yes.
So I'm saying you personally. So we're not talking about any grid. We're not talking about any grid. I'm saying if you were to follow a line of longitude from the equator.
Compass,
oh,
you can measure it with a basic compass.
Right, here we go. Let's try it again. If I gave you a theodolite and I said to you, we'll take a measurement of the angle to Polaris relative to the horizon, assuming you weren't going over mountains and things, relative to, say, if you could go over sea all the time, and if you followed a line of longitude, every 69 miles you went north of the equator, that the Polaris would or would not go up by 1 degree. Do you believe that or don't you?
It'd go up by 1 degree to what you're saying it, yeah.
So why were you making
in your view?
Rumpus, you didn't even listen to what he was saying. He literally says, as it gets to the horizon, it starts quickening up. And you just went off on a massive 10 minutes worth of talking in your own ear. He was perfectly right.
Hold on, when you say quickening up, you mean its velocity in terms of when the dusk or something? Is that what you're saying? When you say quicken up, what the hell does that mean?
It's when refraction, you idiot.
Yeah, exactly. When it approaches the horizon.
I didn't hear. I can't hear. There's too many people talking. I didn't hear what he said.
Or quickens towards the horizon.
What do you mean quick? Sorry, what do you mean by quicken?
So when you observe
we're not talking about anything with speed here. We're just talking about moving by 69 miles north. Does the angle to Polaris relative to the horizon change by 1 degree or not?
Yeah, but what does that prove? Because
it proves you can't get a flat Earth because that doesn't happen in this model.
No, it doesn't.
Hold on,
in the fake model you just made up.
Move this by 69 miles. The angle to Polaris will not change by 1 degree. It'll change by the arc. It'll change by a tangent. Jesus Christ, you're a moron.
You can apply a grid to any landmass. You can apply a grid, a relative grid to any landmass.
Simple trigonometry, and that on a flat Earth, that if you moved along here, the angle, hold on, the angle.
You can't rely on that grid.
Hold on, the angle, hold on, the angle would change by a tangent. The angle would change by a tangent, whereas on a spherical Earth, it won't. It'll change by a constant value.
How can you say that? How can you just say that it wouldn't change by 1 degree on a flat Earth? The observation is that it changes.
I'm showing you the diagram of what happens.
It doesn't prove the shape of the ground underneath. The observation is the angle changes. It doesn't prove the shape of the ground under your feet.
You don't understand trigonometry. If you don't want to accept trigonometry, then you're a moron, and you're not worth talking to.
Can I just get Rumpus here? I already asked him a question, and we're deviating here. This is exactly what he's completely not even adding into the equation of this bullshit presentation. Listen, you just said the apparent junction is caused from curvature, right?
Okay, that's a separate subject from Polaris, but okay, we'll talk about.
No, it has everything to do with measuring angles. Your apparent junction of the sky and ground is based on the observer's limited vision. Okay. You're claiming it's Earth curvature, and I want to ask you, where does perspective fit into that answer if you're claiming it's Earth curvature?
Irrelevant.
It's irrelevant. Okay, thanks, Rumpus. You just prove yourself fraudulent when you respond in that manner.
Just prove you're an idiot. You don't know what you're talking about. I can show you exactly.
So I asked you a very simple question. I asked you what causes the apparent junction. The definition of horizon. The definition of horizon in any dictionary will tell you it's the apparent junction of the sky and ground, meaning it's not a physical thing. It's an apparent junction. You claim this non-physical thing that's apparent is a physical thing. And then in the same breath, I ask you, how does perspective rely on it? And then you have the nerve to call me an idiot. You have to be one of the biggest morons I've ever encountered in this world besides Sean Hawkins.
Yeah, but you're a moron. You're not qualified to have an opinion. Right, so here we go. What's happened there?
Rumpus, you prove yourself daily that you're not worthy of an opinion.
Yeah, hold on. I was just about
to daily.
Hold on. I've just been.
Can I show my diagram, which works on a flat Earth?
No,
everyone can do maths.
No, it doesn't work on a flat Earth because you use the results for a spherical Earth and you stick them into your flat Earth model. It doesn't change by 69 miles per degree. You've just put that into your thing. If you look at the trigonometry,
I've accounted for the apparent rising floor. You haven't accounted for any perspective. You've accounted for someone at 6 foot seeing 6,000 miles, and that is nonsense. You cannot see 6,000 miles of the floor. You can see 3 miles of it from 6 foot. So yours is nonsense. Yours is make-believe, which is rubbish.
just.
You don't represent reality at all.
90 degrees below
You
Polaris
are
reality is not 90
a Muppet
degrees
rumpus
on the grid.
of the grandest scale.
Right, so here we go. What is going on here?
And Hawkins is the same. He says that he's debunked my trigonometry, and yesterday he blatantly admitted in Jose's side chat, yeah, I know what trigonometry is, you idiot. I just don't know how to do it. So how could you debunk trigonometry when you don't know how to do it?
Right, so here we have the horizon. This is how it occurs here. So if you see this diagram, here we have an observer at a particular height, and here we have an object in the distance, part of which
so
is
an observer
at
6 feet high on the beach, the horizon should start no further than 3 miles out.
Can you point where the Rumpus, can you point to me that section where it says apparent horizon? Can you show me that where it shows that it's not a physical obstruction, but it's only apparent due to perspective? Do you have that in this
nothing
drawing?
To do with perspective. You can see there's nothing to do with perspective in this diagram.
Oh, I know your drawing has nothing to do with perspective. That's the issue there, bud. You need to start adding it in.
No, you don't.
No, you do.
No, you don't. You don't understand
it. Yes, you do.
So here we have the horizon. Here we have the horizon.
You're negating vision in all of this.
No, I'm not.
You're
negating that building there.
You are using geometry and not optics.
Right the hand.
You're using geometry and not optics.
Draw diagram.
Why would you do that? Why would you do that? Why would you use geometry? I don't know why.
I challenge you to draw.
I know why.
I challenge you to draw.
Why do you use geometry and not optics?
I challenge you to draw a diagram in which you've got the observer.
Why don't you use optics, Rumpus?
I challenge you. This will make it clear to you. I won't have to explain. If you understand the
clear why you don't use optics, are you going to tell me why you don't use optics?
If you understand,
are you going to tell me why you don't use optics?
Understand my challenge. You'll realise I'm correct. Try and draw a diagram. Present to us a diagram in which you've got the observer and something they're looking at, and you'll see you have to use an orthographic diagram.
Why do you negate optics in your orthographic drawings? We see with our eyes, Rumpus. We don't see a physical ball.
And the way you
see an apparent effect.
We
see an apparent effect.
I'll give you an answer.
Due
you just asked me a
to
question.
limited angles of light.
You just asked me a question, then you interrupted my answer. One word into my answer. Right. So you asked me why I ignore optics or something. Right. I don't. But
why do you ignore optics?
I don't.
Yeah. Why do you ignore optics? There's no optics in your picture.
Yeah, this is optic. It is because this is called
There's no optics. There's nothing.
No, this is you don't. Do you know the difference?
This is geometry. This is
Narnia
land.
Geometrical optics, wave optics.
There's no optics in this photo.
This is called geometrical optics. You don't obviously understand the definition.
Where's the eye? Where's the eye?
The eye is here.
Where?
There. Where
is it? And where's your apparent horizon where the clouds apparently touch but don't? Where's that?
This diagram does not allow for refraction. This is a purely geometrical reflection. You want me to show you one that includes...
You are insane.
If you want me to, I can go to one that includes...
You know what? It's sad. So sad now. It's so sad, Rumpus. It's not even funny. It's becoming sad. It was funny for a while, and now it's just sad.
Back from the argument because you don't like it.
No, dude. You're not using optics at all. You're not even using reality.
You don't like focusing on the argument. You deflect from the argument because you know, I think deep down you know you're wrong. So this diagram doesn't include refraction. I'll accept that because this is one of my first diagrams in the series.
Deep down inside, I can't wait for the world to see people like you are trying so hard to lie to people.
It doesn't include refraction. This is just the geometry.
It doesn't include optics either.
I add refraction later, but this is the simple starting diagram for morons like you, where we demonstrate we've got an observer, you've got to have an observer in the diagram, and you've got to have what the observer's looking at. And I challenge you to draw a diagram that doesn't produce something similar to this, and then from this diagram, you can then work out what the perspective. If you want to work out, so for instance, later on in my little thing here,
can I show you something? Can you go to any Earth curvature calculator right now, just for shits and giggles? Can you go to Walter Bislin for me, since you're up on live there? Could you just indulge me in this little wonderful thing? Can we go to Walter Bislin's Earth curve calculator?
Because I'm such a generous character, I will do that. Even though you've interrupted me giving a presentation and you're an ill-mannered yob, I will still do it because I'm such a generous character. Okay?
Right on. Okay, so just do me a favor, and you can actually go to the flat Earth model too. And when you're in there, when you're in the flat Earth model, just go to miles, and can you go to 1 foot 1 mile away for me?
Here we go. Let me share. I'm going to reshare the thingy. Hold on. Change what I'm sharing. So I've allowed you to rudely interrupt my presentation, but I'm that sort of kind sort of guy. Don't know quite why I'm so nice, but there we go. I can't help it. Right. So here we go. I've now gone to the page you've requested. Is this the page you've requested?
Go to the flat Earth calculator and go to miles for me for
down here. Is this it?
Yeah, go to the flat Earth one.
But it is the flat Earth. This is the flat Earth.
Awesome. Now, perfect. But put it to the miles for the measurements. Go to metric there.
I have not used this recently.
Keep going down. So see how it's got the little buttons there? It says FE.
Oh, units. Units. You want me to use statute miles? Is that what you want?
Well, you don't go there, but just go to you'll see it there in the selection for your. It should be right there. But anyway, type in 1 foot, 1 mile.
Hold on, well, I haven't found the stupid. Where are the units? Where the hell's the bloody units you use in this? Well, if you're so familiar with it, you tell me where it bloody well is.
Well, you're in. Don't go to units. Just go to the first one, the first category.
Well, there's views. So you tell me where the bloody units are then.
He must have changed it. Well. So see how it says model, globe, FE, globe, FEX, globe, FE. Yeah. Oh, he's changed it. He's gone and changed quite a bit now. He's added quite a bit. Look at that.
Yes, I'm supposed
He's put a theodolite now. He's put, wow, they're really studying our conversation. That's pretty fucking amazing. Look at all the stuff he's added. Anyway, if you go to the units, and if you can get to miles, which it says miles already. No, go back to views. You're already in miles, it looks like. Are you in miles?
No, I'm not. It's showing everything in meters.
Meters. Okay, so then...
Yeah, so if you know this, why not tell me...
No, he changed it. He recently updated quite a bit of it. Wow, that's too funny. So just see where it says FE there. A little highlight the FE.
There, right, okay.
Right, that's the FE version. Let's see what he's done. Because what happened was... so I apologize, it's not working. I haven't gone to his site in a while, but previous to it, he had the go to miles. You put in 1 foot, 1 mile away, and if you go and look at the geometric drop, I want to highlight the geometric drop on this model.
Well, there can't be any geometric drop on a flat Earth, can there?
So, well, that's what I mean. So there's a geometric drop on his flat Earth. There was.
So and we don't know what this is doing. We'll give up on this then, and we'll go back to
No. It's there. Hold on. It's got to be there. The miles thing. If you want. The whole point is seeing the 1 foot, 1 mile mathematics for it, because you're claiming that Earth's, a ball, right? It's a physical, tangible ball, correct?
It's a ball. It's a thing you play with in a game. It's a sphere.
It's a planet.
What? It's a planet.
Which is sphere shaped.
Right.
Or blade spheroid.
Yeah, laugh it up, fuzzball.
Yeah, right. There's the pecker. There's the peckerhead I'm trying to get on
these
on
guys
record
sort
here.
this out. Big thank you to Dowjin for smashing the super chat. Awesome, mate. Sorry I can't start over, but you can watch it back on the re-upload.
Unequivocally say that if you were physically at 90 degrees on the GPS grid, do you understand me now? If you was in a boat and you were physically at 90 degrees on the GPS grid, can you unequivocally say to me now and tell me without any sort of, without any sort of doubt in your mind that you would actually physically be 90 degrees below Polaris in reality?
Well, Polaris isn't quite on 90 degrees.
Well, that's what all the measurements are based off, because all the measurements...
It's close, but you said exactly, and I'm very careful in what I say. So when you say exactly 90 degrees, I know that Polaris isn't actually quite... It's
give or
half
take,
a degree off. It's a half a degree off or something.
Give or take 1 degree then, say.
Okay, yes.
Would you be within if you were at 90 degrees on the GPS grid, physically, in real life, can you unequivocally say that you'd be 1 degree from underneath Polaris, from off 90 degrees? Yeah? So you'd be at 89 degrees to Polaris.
Yeah, I mean, I can't remember what the angle is off the 90 degrees, but yes, if we said the Polaris, let's just for the moment.
Hang on.
Let me just hold on. I'll make it easy for you. If we say, hold on, let me just make one thing. Hold on. If we say hold on, just for 2 seconds. If we just pretend for the moment, hold on. If we just say the Polaris, hold on. If we just say the Polaris is
if we say the Polaris is exactly...
Show me a photo of Polaris 89 degrees.
Hold on. If we just say for the sake of this discussion, the
we're not
Polaris
saying for the sakes, we're talking about physical reality now.
Then yes, it would be exactly 90 degrees if we say Polaris is exactly on the...
Can you show me the evidence for that? Can you show me the evidence someone being exactly 90 degrees below Polaris? Please. Or 89 degrees below Polaris. Just to prove that the grid starts
a picture
90 degrees below Polaris.
Okay, to prove it to you, I'd have to show you a picture with a theodolite, which has been calibrated exactly, showing you the zenith angle at that point. So I don't have a picture showing that to hand. But if you're just
a GPS logged picture from 90 degrees would do, wouldn't it?
Well, yeah, but you'd also have to show that you were pointing directly up, wouldn't you?
Well, you'd have to be, wouldn't you, if Polaris was directly up above you? If you knew you were at 90 degrees,
I'd have to prove to you two things.
You'd have to be 90 degrees below Polaris.
To prove that to you, you'd want a picture that was verifiable, that showed something like a theodolite, showing you a zenith angle, pointing at Polaris and say, this is Polaris, and this is then showing you on the readout of the
theodolite. I wouldn't need the theodolite.
Finish that goddamn sentence. Right, so I'd have to show, to prove it to you, I'd have to show A, that the observer was exactly at the North Pole. Then I would have to prove to you that the theodolite, whatever they was using, was showing a value of 90 degrees. And 3, that they were looking at Polaris. I do not have those three, a picture with those 3 things in it together.
Welcome to Flat Earth.
On assumption. So then your grid's based on assumption. You do not know 90 degrees of the GPS grid is 90 degrees below Polaris in real. You don't, and that's why true north is a few degrees off magnetic north. Grid north is a couple of degrees off magnetic north because it doesn't sit right.
Hold on.
90 degrees isn't below 90 degrees Polaris.
You've just introduced magnetic north. That's got nothing to do with what we were just talking about.
That is reality, though. Magnetic north is the real north. That is reality.
We're talking about true north, Polaris, and the Earth. That's got nothing to do with magnetic north, you utter red herring moron.
No, it isn't at all. I'm not. You don't even know what I'm saying.
I do know what you're saying at all. Magnetic north into the axis
true
of the
north,
Earth.
grid north applies to the GPS grid. Magnetic north is the real north. You wouldn't have north without magnetic north, you plum.
The real north is very close to
have north without magnetic. You wouldn't even know what north is without magnetic north.
The fact that you brought magnetic north into the discussion means you've no idea what you're talking about, and you're a moron.
Jesus. Not at all, Rumpus. You are a moron, mate.
How are you feeling, Rumpus? Are you feeling all right?
Yeah, I'm feeling a bit better actually. I'm gradually recovering. I'm having to deal with this moron who thinks magnetic north's got something to do with the GPS system and Polaris and the axis of the Earth.
Did it say that?
You mentioned brought it into
the fucking idiot.
So you think
it's relevant? That, you arrogant twat.
Think it's relevant? You brought it into this.
Shut up for a second.
Does anybody just out of interest?
Shut up.
Just out of interest. Does anybody know how GPS satellites work?
Through trilateration.
Okay, and how would we do that as an individual? How do I determine my location on this body of land?
This is Dean, anyway, right? Above. This is Dean, right? You can't determine your location above Greenland anyway, mate.
Dean, that's what I'm saying. How many satellites do I need for an accurate position?
That would depend.
Compass and a map.
How many satellites would I need? Balloon satellites. How many balloon satellites would I need for an accurate location on Earth?
Balloon satellites.
Yeah. I'm just clarifying my position. That's all.
You can do it with ground-based radio.
Yeah.
Right? Okay. So my question is quite simply this, and it's okay to say no. Does anybody here know how to determine their location by using either the GPS satellite network, GLONASS, or Galileo? Anybody?
Never used it. Including you, no one knows. So yes, you just answered your own question. No one knows.
Nobody knows. Okay.
So Dean, hold on.
So wait a minute.
That doesn't mean proceed. That doesn't mean proceed.
I have one question. I have one question for Dean. One question for him. Okay. When they're, what is the fundamental part of trilateration in the mathematics? How do they measure the angles to the satellites, and why? Sorry, it's two questions in one.
It's not angles. It's not angles.
Hold on. Okay, wait a second. So you're telling me the law of cosine does not apply to the trilateration of GPS?
You don't measure the angle to the satellite.
That's not my question. That's not my question. My question, you're telling me the law of cosine do not apply to the trilateration of satellites?
It does do, but only once you're two steps down.
Hold on.
Two steps down.
Post-processing.
The law of cosines.
Listen to this. Let me ask you a question.
The law of cosines are straight lines and angles. Okay, number one. Number two, why does it require more than 3 satellites to locate one position on Earth?
The time difference. You need to average it. You need to synchronize on one timestamp, and then get three or more fixes from the others once you've synchronized off one.
So time is the reason.
Time.
That's it, right? Time.
Yes. Nothing
to do with the diffraction or refraction of the signal at all? No? That's why you need 3-4 satellites to determine one location?
It's to do with the variance and error tolerance.
So listen.
Because,
now, the variance, hold on.
Because they're 12,000 miles away.
Yeah, exactly. Let me finish. So, Dean, it's not very reliable for ground positioning, is it? Using satellite data for ground positioning. Because you mentioned, you mentioned time. You mentioned time's an issue why they can't coordinate positions. And what was the other one? You guys are so disingenuous. The reason why they use GPS, ground positioning, for locations is because they don't have to. They don't have to account for any of that nonsense when they use Cartesian grid, GPS-based ground systems. That's it. There's no when they go to calculate using the law of cosines.
Okay. You've got me. You know how ground positioning systems work.
No, I'm just saying that's why they use. I'm saying that's why they use ground positioning, because they need 3 or 4 fucking satellites to find an actual location. They don't need that with ground towers, you moron. So number one, they use ground towers.
They don't need it with ground towers. Fucking hell. Let's just hope I don't. Let's hope I don't go down the Grand Canyon and need to know where I am.
Final question.
Oh my God. Oh no, because the Grand Canyon's lined with radio antennas to do this, right?
Final question.
Oh, that's right. Radio waves bend round and go down the canyon. That's right. Oh no, wait. All of that's bullshit. Thank you.
So listen, what causes the apparent junction of the sky and ground? Is it Earth curvature, or is it your eyesight?
Does anybody know how the global positioning satellite systems work?
Why don't you answer?
Yes or no? You got
yes.
right there, right to hand.
Use radio frequency triangulation.
Right, and how do we triangulate? What are we triangulating from?
From a
you use ground towers. Number one. You use ground towers, number one. They all come from the ground towers, bud.
How do I get the triangulation? What component do I use?
You just use frequency bouncing.
Receiver.
All right, so wait a minute. All I do is frequency. Okay, so frequency of a satellite signal, 1300 megahertz. What do I do with that to figure out where the fuck I am?
They're looking for where they cross. They're looking in trilateration. They're looking for the cross section of the signal connection. Correct?
Okay. So wait a minute. What aspect or what component am I cross-sectioning there in that trilateration?
You realize you just have a receiver, right? You have a transmitter and receiver, right?
That's it. Yeah, and it's just a frequency. The longest frequency I've ever seen.
Oh my God! How do I work out where I am?
To reduce diffraction, to reduce radio frequency diffraction, right? They don't want to shoot it up in the sky, dude. They don't want to do it in the sky.
I'll ask this one more time.
I'll tell you.
To triangulate my position on the ground. If you do not know, just say, I don't fucking know. It's easier.
If the object in the sky you're using is a satellite or a high altitude drone with radio frequency equipment on it, does it make a difference? No, it doesn't does it?
Yes,
you don't know what the fuck's flying around up there, pal.
Absolutely. No, wait a minute. I couldn't do it on that.
It's the signal that's coming down.
You're missing the one. You're missing the one.
No, you don't know what's up there. You're missing the one component you require.
Listen, let me know when I can talk. Go on.
This guy's such an idiot that he's telling us that radio frequency signals can go 12,000 miles out to a straight beam to something, but not go across a straight plane Earth. You are a moron and a disingenuous fucktard, dude.
I'm telling you.
I'll tell you what. Go figure out. Wait a minute. Listen. Go figure out why I can get GPS signal in the Grand Canyon. Please, go for it.
You're an idiot, mate.
Go for it.
Please tell me how that quantifies. Please tell me how that quantifies a sphere, you moron.
Tell me why. I haven't mentioned fucking sphere yet.
Tell me why it quantifies a sphere.
I haven't mentioned sphere yet.
The point is, you're quantifying. Listen, dude, we're not debating whether or not you can bounce signals, dude. We're not debating that. We're not debating any of that shit, dude. Wake the fuck up. You're quantifying GPS as evidence of ball. You're asking GPS for. Listen, you're an idiot.
You're obviously thinking.
I didn't know we were going to get you this trigger. It's a simple answer.
You're the one who has to lie, buddy.
Get to your point.
Okay. I'll ask it one more time and see if anybody can answer. What are the components? Go on, Gleem.
You basically have a receiver in your phone. You have each of the set. Wait there. No, hang along. You probably interrupted everyone. That's probably what made it long. But anyway, you have all these satellites which are pinging out their location. You then grab all of these different radio signals hitting you all the time, every split second. And then within your phone, it says, I've got this satellite here, I've got this one here, and I've got this one here. I am doing a calculation to say where I am.
And what's it? Yeah. So that calculation, how is it doing the triangulation? There are components that are required to do that triangulation. And it's very important. There's steps to get to this component. What is that component?
It needs to have the implemented grid system inside in the software.
Dean, he did say that the satellite transmits its position.
Yes, but the component is distance.
Yeah,
and that is derived. Actually. Well, no.
You were acting like it was a device component.
No,
that's what.
Exactly.
Oh, sorry. No, don't mean hardware. Sorry, if that's why I came across.
That's
I apologize.
what threw everything off. Yeah.
Right. Okay. I apologize. So the component or the triangulation component in that calculation is distance, which the satellite says, I am here, I am on this orbital path, and I am 12,000 miles away, or it could be 13,000 miles away, or it could be 11,000 miles away. It depends where it is. And you get that from, it doesn't actually say I am 13,000 miles away. It transmits a timestamp. Now, based on that timestamp, you have to work out how far away that is based on the speed of
Dean, I think it does. Dean, it surely transmits.
Listen, you could just be following a signal bounced off the ionosphere.
Yeah, but Dean, if it just transmits its timestamp, that'd be useless because you need to know where it is.
You could just be following.
No,
you don't, Rumpus. You're wrong.
No. Okay. So anyway,
following up there. You just following.
But Dean, it must transmit its position.
Yes. No. Okay. If you're asking me what a satellite transmits, the packet data, which is open source, is orbital ident, satellite ID, grouping network, the orbital altitude. Listen, the orbital altitude, and about 3 or 4 other things.
Frequency.
Yeah, it's got to transmit its position, Dean.
Yeah. No, it does all of them. That's what I say. But the component.
Someone was disputing that, and it does.
It doesn't matter about the packet data.
All right. So the most important thing there is the distance, because once you get the distance from 4-5 known objects, you can then triangulate your position. However, if those
don't know them objects,
Dean, I don't think it can transmit its position. It can't transmit distance because it doesn't know what it's talking to. All it can say.
The objects.
Oh my God! You work out the distance.
Dean is right. Dean is right.
Shut up, Rude. Dean, surely, all it's got to do is to transmit its position and then a timestamp. And then then only the phone knows what the distance is because it only knows its position.
Yes.
Right. So it doesn't transmit its distance. It transmits its position. I didn't
say it transmits its distance. I'm saying
that's just software, though.
To do the triangulation, you need to convert that into distance.
Right. So it doesn't transmit its distance, does it?
No, it doesn't transmit its distance. I've told you, it transmits in the packet, and everybody can read this. You can point a dish up.
No,
let's just say we don't know what's up there. But let's say we point a beam antenna up there with an LNB in a focus receiving beam. We can get this information back, and it's open source. Anybody can read it. You could go out and spend £2 and get this crap and read it on your.
I think we're getting off track, Dean.
No. So the point is, if those distances and that time to work out those distances was not correct, I would not be able to know where I am on the ground. And the amazing thing about this
because you can't verify
the amazing thing about these
coming from and what
the
is
amazing
cannot verify that. That is what it's about, mate. It's not about the signal being there.
Earther, why do you
let
Dean make his point and then you can have your
No one's
turn?
asked about how triangulation
Why don't you
works,
let Dean finish and then you can have a go?
So
because you spoke all night and I've stayed quiet for everyone.
You just
nothing.
keep on interrupting.
Now we're talking about radio frequency.
So
keep on interrupting.
I'm going to help you guys here. All you need to do to invalidate the globe, quite simply, is invalidate the GPS, GLONASS, or Galileo satellite positioning networks. However, you need to understand how they work first. You can't say ground-based antennas. You can't say yes. Everything uses radio frequencies. Well done.
It is. That's what it is.
Yeah, radio frequency.
Dean, let him have a go because he's not going to shut up.
So, Dean, to clarify, when you're using the law of cosines to measure a distance to a satellite, it's in a straight line, right? And you just said it's about what? Satellites are about 12,000 miles up. Did you say?
Yeah.
So wait a second.
Orbital
how high are these satellites again?
12,000 miles. It depends which network, but yours so they have 12,000 miles.
Awesome. So they have satellites going up in your mind. In your mind, there's satellites 12,000 miles up that you can use a straight line of geometry to find their position to, right?
I can find my position by getting their distance to me and other satellites to triangulate.
Using angles and straight lines, right?
Yes.
You don't need angles. So listen.
No.
Listen. In 1901, Marconi did a transmission, right? This was way less than 12,000 miles. The only way for a signal to get 12,000 miles out is a straight path to an object, right?
He bounced it off the atmosphere, you idiot.
12,000 miles up, he bounced it off, and it hit the satellite.
Atmosphere.
So
Jesus
what's the point
Christ.
of using straight
Every
lines?
radio ham knows this, you moron.
So the point of the matter is you can send a signal in a straight path because you're measuring in a straight path using basic angles and law of cosine. The 1901 Atlantic transmission of Marconi was an extremely way shorter distance, and you guys are claiming that our signals will curve around the Earth.
At a particular time of day, so
they don't curve around the Earth. No.
Okay, good, because you know what? If you read these articles, when they did make the connection, the scientists of the day said that. First of all, it wasn't possible because the curve would interfere with the signal.
Because it didn't happen. They had to go in a particular time of day when the atmosphere was in a particular ionized state that it would work. It would not work all the time because some of them knew that it was bouncing off the ionosphere, which doesn't always do that for all times of day.
So the way the tower was set up.
For the GPS system, you cannot rely on bouncing off the atmosphere. You want to
the way Marconi's tower was set up,
use bouncing off the atmosphere techniques. Jesus.
So you think you can bounce? You think you can bounce?
Wait a minute,
you can bounce radio frequency from the UK to Australia because that's the longest distance one's ever been sent.
Wait a minute.
Radio frequency, the longest one that's been sent. UK
right the hand. What's the relevance of this transmission that you're on about?
It's flat Earth data, dude.
Oh shit, flat Earth data. What's the relevance of that you just mentioned in relation to global positioning?
I'm just documenting you. I'm documenting you, dude. I'm documenting in your doublespeak.
Okay.
And so finally, why don't you answer my question? What causes the apparent junction of the sky and ground? Is it Earth curvature or is it your eyesight?
It's the physical depth difference between the ground and the sky that I observe optically. Why?
Optically, perfect. Maybe about an hour ago, 45 minutes ago, Rumpus said it was Earth curve. So why don't you educate him on how it's not Earth curve? Can you share that with Rumpus?
Yeah, I won't call it curve. I'll just call it physical obstruction. It happens to curve and conform to a planet, but I won't call it Earth curve.
No, you double spoke again, bro. You just said
I said
physical curve and then optical.
No, I said.
Go back and listen.
I have to. Listen to this. Wait a minute. Flat Earth.
Go back and listen.
Listen to this.
Data. Get it right.
Flat Earth data. Listen at this. I see a physical obstruction optically. I don't know how to say that clearer.
No. You see a physical obstruction optically. So what is it?
If I hold a basketball in front of your face,
why is it called apparent?
I am optically seeing a
why is it
physical
called
object block you.
Why is it called apparent?
Because it is apparent to the physical object.
What's that again?
So a physical horizon on your sphere Earth for an observer at 6 feet height at the beach should start at 3 miles out. Why doesn't it?
Because of refraction.
No, that's bullshit. Refraction can only be demonstrated when an object passes through two mediums.
No.
Hold on, Dean. Hold on. Who's that? So we've got. So this is Rude Earth. Whatever it is. You're saying that you only get refraction when you've got two different mediums. Is that correct? Is that what you're saying?
That's right. That's right.
So how do mirages form? You flipping stupid.
Mirages are an optical. Mirages are just an optical illusion. It's nothing to do with refraction, is it?
Oh my God!
Refraction isn't a mirror image.
Mirages are nothing. Refraction
is not a mirrored image. Refraction is not a projected mirrored image.
Oh my God!
No, it
not
isn't.
qualified to talk to us.
No, wait a minute. Rumpus, just stop 2 seconds.
You provide a physical
honestly,
demonstration
just 2
of
seconds.
refraction. You put a pencil in the water experiment. Is a prime example of refraction.
Just 2 seconds. Just 2 seconds. Just what you said. I need you to go and learn a little bit about refraction. Mirage is refraction. Mirage affects our refraction. Refraction refers to the bending of light. In order to get a mirage either inferior or superior, that requires the bending of light under the encapsulation of what we call refraction. We can also have looming.
Can that be recreated? Can you recreate a mirage? Can you recreate a mirage in lab conditions?
Please go away and learn about refraction.
Can you create a mirage in lab conditions?
You are an utter moron.
Right,
Denying mirages using some other mechanism besides refraction. You're an utter moron. You're not qualified to talk to us. You're not. I'm a mate.
You're not qualified to talk to you. Shut up, you
utter moron. Utter moron. God.
You fucking imbecile. Shut up, Rumpus.
Here's how both
not
of you
qualified on YouTube.
Fucking arrogant moron.
Yeah, exactly. Rumpus has been qualified by claiming perspective is responsible.
To speak to you prat.
He's claiming that Earth curve
autism sufferer. You fucking idiot.
Rumpus claims that Earth curvature
is your opinion. You're too stupid to talk to.
Rumpus, you're documented claiming that the apparent horizon is because of the physical Earth curve. And not perspective.
I'll show you.
Then you're documented. Then you're documented.
Flat Earth data. Sorry, I've just come into this. Flat Earth data. What the fuck has perspective got to do with it?
Got to do with what? Just to clarify, what are we talking about?
You said you're on about the physical horizon obscuring things, and then you said perspective. What?
No, I wasn't on about the physical horizon. I'm on about the apparent horizon.
Whatever. The fucking horizon.
Can I show you?
What's perspective got to do with it, please?
So, what does perspective have to do with the horizon? So,
what
Dean,
does perspective have to do with geometric occlusion? Yes, that is what I'm asking.
Wait. So, geometrical occlusion is now associated with horizon. So,
physical occlusion, whatever the fuck you want to call it. Me not being able to see shit because of something else. How's that?
Adjunction. So just to clarify, the reason why the clouds appear to touch the ground is because of a physical interaction and not a perspective interaction.
What, like the ground fights with the air? What the fuck you on about? Physical altercation. What?
Calm down, guys. Calm down. Take a deep breath, all right? Take a deep breath.
Right,
so listen, when I stand in a hallway and I see the apparent convergence or the vanishing line of that hallway.
Yeah.
What causes that?
I don't give a shit. I don't give a shit. We're talking about.
Thank you, buddy. You are busted as another fucking fraud.
Sorry.
Live,
in the hallway,
real time, again, being a disingenuous retard.
Can I ask a question?
In real time.
Can I ask a question, please, sweetie?
Do you know what
in that hallway, sweetie, can you point to the bit that occludes something else, sweetie? Come on,
you are what's
just
called.
one thing.
You are what's
Does the floor occlude the floor?
You are what's
Does
called.
Does the roof occlude the floor?
You are what's
Wait a minute.
called.
What moves in front of someone else?
You are what's called.
What's he called?
You are what's called a government cuck. You sick fuck.
I've got a diagram here that will explain.
Go read your Bible and treat people with respect.
Right, can I show you?
Go cuck somewhere else, you weirdo.
I'm about to explain to you where this geometric stuff gets involved and refraction gets involved. You can see here in this diagram.
Rumpus, a mirage has never been created in lab conditions. The only physical
you denied it. You denied it in the atmosphere.
Experiment.
You denied it in the atmosphere. 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 Right, so in this diagram, I've got this feature.
Show me a mirage.
Hold on, I'll talk to you in a second. I'll talk to you in a second, but I want to explain the flat Earth data. Yeah, I'll talk to you in a second. I'll talk to you in a second. Right, here we have in this diagram, we have an observer who's looking across here at an object over here. And the yellow portion here you can't see because the straight line,
I'm not blaming your balls, man.
The straight line touches here at the geometric horizon. And that's with no atmosphere, no refraction. So you can see here, this part of the physical part of the Earth is obstructing. Now, the Flat Earth data was quoting lots of Nathan Oakley edits, which I was only able to give one-word answers. But if you have refraction, so here
that's bullshit, dude.
Here we have
Flat Earth data shit.
Here we have the base of the a lighthouse, and as you can see, the light
Mr. Bean, nobody has ever recreated a mirage under light conditions, Mr. Bean. All the physical examples of refraction are silly little experiments, Mr. Bean.
If you have a big enough lab, you can do it.
Right. So here we have the a straight line with no refraction.
Listen. How is refraction measured?
It doesn't matter. I'm going to explain.
What's called it needs a plane surface.
We'll
it needs a plane surface with what's called the normal, right?
I'm talking. You can make your point afterwards.
Man, this is just nonsense. This guy's nonsense.
Right, so shut up. I'm making a
point. Nonsense.
Good argument.
Nonsense.
Very intellectual.
Good argument. I've already destroyed this a while back. He's just repeating himself.
Right, so here we go. So the reason
what was your argument, Dean? What were you going to do? You can't answer what causes the apparent junk.
So here we go. Here's what
can I test this, Rumpus?
It's fucking
right. You keep fucking beating me out of the chat, man.
Can I test this, Rumpus?
Oh, right. I'd like to give an explanation. I know that Flat Earth Data doesn't like this because it'll expose his idiocy, but I would like to just make the point.
The guy who doesn't add anything to do with optics in it. Orthographic Muppet vision.
No, I'm going to test it. I'm going to test it, Flat Earth Data. Watch this.
Optics. This is geometrical optics. So, in geometrical optics, you use straight lines for the rays of light. So here we have a ray of light that goes from the observer, comes from the horizon to the observer, and you can see that is at 90 degrees. So anything in this yellow area cannot get to the observer using a straight line. But if you have refraction, then the bends around the curve, then you can. The base of this lighthouse, the light from it bends around the curve and gets to the observer. So this is the apparent horizon at the base of the lighthouse, and the geometric horizon is up here. But so when you have bendy light, then you do not have a geometric horizon, you have an apparent horizon, and you can see that it's much further around that the observer can see with refracted bendy light. But it's still caused by the geometry of the Earth. It's still a part of the Earth that's causing it. This is a new tangent here, so it's still part of the Earth that's the horizon. It's just a different part from the geometric horizon. Thank you.
Okay,
so how far away from your eyeballs does this refraction start?
Who kicked me, by the way? Was that you, Ranty?
No, I'd like a citation for bendy light, though. No, I haven't booted anybody, so...
Yeah, and someone's booted me as well.
So, yeah, I want to see that citation as well.
I want to see a citation for bendy light, please, Rumpus.
Hold on, you're disputing that light bends.
No. You just mentioned it's bendy light, and you mentioned it a couple of times towards the end of your presentation, and I just want to see...
The ray's bending.
No, you said bendy light. I want to see the citation for bendy light.
I'm trying to... Yeah, and I'm referring to a ray that's bending.
No, concentric with Earth curve, man. Not just the rays bend.
Right. Even the diagram of a mirage, of a mirage doesn't show the image being projected forwards towards the viewer.
Okay, I've got a ray tracing diagram for you to show you exactly that.
Ray tracing diagram. I'm talking about the one given on the internet, mate. By the system, not Rumpus's
I'm about to show you a diagram that's much better than anything you'll find on
drawn in his bedroom.
Hold on. No, I just want to do that impersonation. Sorry.
That was terrible. That really was.
So is there no citation for Bendy Light then?
When I was referring to Bendy Light, I was using
Superlooms, Ranty.
I was dumbing my language down for the morons in the chat. It's light.
Rumpus, you're not the authority on refraction, mate. You're just some guy
is his citation.
from the UK. You're no one.
Idiotic PDF.
So here we have
exactly right.
This diagram.
You can't just draw drawings and expect everyone to conform to
any
your drawings.
diagram you will find on the internet, because this is modelled on an observation of the Isle of Man, in which we actually took the temperature parameters and then actually created the rays of light from the Isle of Man.
Well, you created the rays of light. You fucking magician. Well done, mate. You should get the Nobel Prize for that.
I should actually. It's quite a good piece of work. So this demonstrates the angle of refraction, the bending of the light here, the bending of the light rays, and shows how they get around the geometric horizon. This is a real-world thing that matches reality, and we actually use this modelling to compare against...
Well, I think we've heard Rumpus say this a few times before, so I'm just going to shout out the super chat from Guns of Navarone RMP. $20 super chat, who says your show is great these days. Thank you very much for the support of the show. Much appreciated.
Overlay your bias modelling and your bias opinion.
Well, Rumpus, the whole it doesn't work, man. It doesn't work, man. The atmosphere is bending, right?
Reality, exactly. It's a fantastic.
But you're saying the density profile. You're saying the density profile is concentric with Earth curve, right? Like at every point on Earth going outwards, the profile is consistent, right? Everywhere across Earth.
I didn't understand.
Is it a homogeneous plane?
Yeah, your density profile that you're applying from the ground up, right? You're using that everywhere on Earth, right? The same one.
In between the observer and the target, yes.
Yeah, so it's a curved strata of that gradient, right?
Yes.
Okay. It's consistent, right, from bottom up, and it's curved.
Vertically, okay, same. Yes.
Right. Okay. So it's a curved density gradient that's applied everywhere along this curve.
Along the line of sight, yes, and it works. Because
okay, so a sniper, when he's shooting, he has to give for curvature, looming of the target, refraction,
no, he doesn't have to allow for curvature.
Wind.
He doesn't have to allow for curvature.
Why doesn't
he? Has to allow for refraction. He doesn't have to allow for curvature. He can see it, but he has to allow for the refraction of what he's looking at.
So you think snipers sit there and write an equation for the refraction?
No,
of the
they
target?
have some complicated tables, or someone with a computer with them to work out what to do.
No, they don't.
Yes, they do.
Squatter.
There are videos.
Hold on, wait a minute. Hold on.
Don't insult me, mate. I know snipers in the Royal Marines. No, they don't have someone with a fucking.
Well, then they're not long-range snipers. Okay, they might be short-range.
Yes, they are long-range snipers.
No, they're not. Long-range ones.
Yes, they are, mate.
There are long-range snipers that need to allow for Coriolis and all sorts of things.
All you have is a spotter next to you, mate. You get some wind and an offset for the target for wind. That's it. You have a spotter to confirm your calculations for wind. That's it, and drop. That is it. Well, you don't have some guy sat next to you with a fucking computer, you idiot.
Some of them, may not do, but the ones doing the long-range stuff do have computers with them that help them out.
How do you know that, Rumpus? How do you know that?
There are videos of people. There are videos of people doing long-range over a kilometre sniping actions that do this sort of thing. And they have big tables with them, allowing for Coriolis and God knows what else.
No, they don't.
So they do. Were you there? Hold on. Were you there? Hold on. Were you there to verify the observations that they put out?
Yeah. Why? He just
or were you taking it on faith?
So he doesn't even know.
There are tables.
Were you taking it on faith?
Well, this guy seems reputable. He's a sniper. He's showing. He shows
no,
the
got
tables.
Plenty of mates in the forces,
and
I know for a fact they don't have.
And we know, for instance, with artillery shells, artillery tables that include things like Coriolis.
He just answered your question. He doesn't know.
I do know.
Well, just
because making shit up, mate. You clown what you've seen on films, you fucking idiot. It's not
the computers there doesn't mean that
it's not walking around with an
reality
and explosive arrows.
There are science and reality denier.
What reality did we deny? He didn't present anything.
Well, he's denying reality. He doesn't.
Well, you just said a computer there that does calculations that only God knows.
Well, I mean,
Bill G. Hold on, guys. Bill G. in the chat says he was artillery in the Marines. We never accounted for refraction or Coriolis.
Oh, there you go, mate.
You don't
got loads of mates in the forces.
They work on GPS. And he doesn't have to do the programming. You put it into your gun where you want the GPS coordinate thing you're trying to attack and where you are, and it does all the allowances for Coriolis for you. You don't have to do it.
Do you know what, you little pen
What do you mean? If you have a computer that can do it, I mean, are you an idiot or something? If you've got a computer,
how did they do that in the? How did they do that in World War II? Hold on, how did it? Hold on. How did the GPS sit in World War II?
Are you not aware?
How did the GPS sit in World War II?
Hold on. Modern artillery guns are very complicated things with built-in computers. You put in the GPS. You put in the GPS of where you are, and it does all the complicated calculations of how the gun should be aimed. So that some guy doesn't have to get out a bloody calculator to do it for him. It's instant. That's the whole point of the computer.
All right, Rumpus, you're overheating, man. You're overheating.
So even wait a minute, guys, just really quickly, guys, from 1980, I'll put this link in the side chat in a second. The computer obtains these coordinates entering the curvature and refraction table on the back of the flash ranging record. These are from even non-modern warfare times. These are just after World War II. I'll post the link. It's a paper that explains all this.
You talk about Coriolis in the classroom, but you don't apply.
No, this is the computer. This is the computer doing this.
They did in World War II. World War One used Coriolis. The battleships in World War One had huge tables. Hold on. In World War One, they had big tables with chunks of metal, incredibly big, trying to work out how to apply the Coriolis to the thing. And using gunnery controls in World War One, they applied the Coriolis thing and allowed for the curvature of the Earth. So, I mean, that's World War One for you. Nowadays, every little gun you've got of the artillery is going to do the same thing. Bill G. You're a reality denier.
Bill G says, I never shot GPS guided rounds. Those things were way too expensive for us to train with.
No, the GPS is the gun. The round is not GPS, you twat. The bloody gun is. Oh my God, who's that?
GPS guided rounds.
Not the round. The gun knows where it is. You type into the gun where the gun
Ranty, the gun flies the bullet
Jesus
to the target.
Christ. Who's this moron in the chat who doesn't know what the hell he's
Rumpus, we get it. The gun flies the bullet right to the target.
This moron in the chat doesn't. He thinks I'm talking about a round that's guided, like a guided bomb or rocket or missile or something. No, we're talking about the gun, you idiot.
Right. The gun is guided.
Christ.
The gun is guided. My bad.
No, the gun has got a computer in it that makes allowances for the curvature of the Earth, refraction and Coriolis, and you just put in where you are and where you want to fire to in GPS coordinates, and it then makes all the allowances you need to make to allow for all the factors involved in shooting something on a spherical Earth that's rotating, and it does all the calculations. Instead of getting someone to get out with a calculator, you just type in coordinate, you type in your coordinate, and then say, right, what angle do I fire? And then it tells you. Jesus Christ.
Rumpus, is there a position or a point or a minimum distance you have to be to use this computer? Could I use it
Rumpus,
at,
this is
2,000 yards?
This is everything artillery give for in the field.
The other guy now, Ruda. You can't even stop interrupting your own Rudas. Karen, what were you saying, whoever it was, Flat Earth Data?
Basically, what I was saying is the calculation for the distance, is it is there a limitation to the distance a sniper can? I mean, obviously it's related to ballistics.
Hold on, artillery or sniper?
We're talking about ballistics related to a sniper, right?
Which one, artillery or a sniper?
So we're relating ballistics to the sniper, like the distance he can shoot. So he uses a computer.
Okay.
He uses a computer, right?
Well, it doesn't happen always. Most snipers do not shoot over 1 kilometer, so they don't need to do a lot of these calculations. They don't need to account for Coriolis. So, for instance, over a distance of 2 miles, the Coriolis effect only caused a change of about 1 foot. So,
listen to my question. Is there let's say in sniper world, since you seem to know a lot about sniper stuff, is there a particular range where they go, okay, no, we can't do this distance without the calculations, or do they have to use the calculations all the time?
Over a kilometer, if they're doing a sniper,
the minimum is over. Hold on, listen. Well, I want to clarify my question so there's no misunderstanding. Okay. So you're saying that for a sniper, he says, "Oh, wait, no, okay, it's over." So over a mile. What'd you say? A kilometer?
I think it's 2 kilometers.
2 kilometers now. Okay,
I think it's that.
He's got a job to do. This sniper's got a job to do, and it's 2 kilometers. So he's got to call his buddy up and they say, "Hey, man, I got a job."
They always work in pairs. They've always got a guy next to them.
Yeah, right. But it's got to be the sniper that gets the phone call, right? It's not the other guy. It's always the sniper.
Hold on. There's a guy with a gun, and there's a guy next to him with binoculars who helps him out with calculations.
Right.
Okay. And so if he's got a range or something that's over 2 kilometers, I can't remember exactly what it is, about 2 kilometers, where the Coriolis effect, for instance, causes a change of 1 foot. So if it's doing a range over 2 kilometers, then say, I now need to make allowance for Coriolis.
Thank you, man. You definitely listen. How are you treating your family through all this? They don't want to. Your wife doesn't want to divorce you yet, does she?
No.
No, you're okay with that. What do you guys do? Does your wife get on the debates?
Now that I've just exposed your idiocy, you now move on to
No, man.
No, Rumpus. This is someone who thinks. This is someone who thinks there's exclusion down a corridor.
Rumpus.
Because he knows he's being exposed to more. Typical tactic.
Rumpus, I'm going to drop a link. I'm going to drop a link in the chat for you, yeah, and it's all about the job of a spotter, what a sniper spotter does. Have a little read of it there, mate, while you're bored.
Okay. But
nothing to do with a little computer and calculations. Just read that little link I've dropped there for you, buddy.
It depends whether the spotter's doing used to long range stuff, or they just.
That is a spotter for a long range sniper.
Some spotters and snipers don't go in for 1 kilometer or 2 kilometers. They just worry about 500 yards or something.
No, you don't have to have a spotter for a 500-yard shot. You don't have to have a spotter for a 500-yard shot. An average infantryman in the army is expected to drop foot shots at 400 yards in full NBC gear. Listen to me, you tit. A standard infantryman in the army is expected to hit a target at 400 yards in full NBC gear. Are you listening to me?
Sorts of snipers.
Are you listening to me?
Now you've allowed me to speak.
400 yards is not classed as a sniper shot. It's a standard infantry shot, 400 yards. You don't need a fucking spotter for a 400-yard shot, you idiot.
I still think if they wanted to be absolutely sure...
Rumpus, no one uses earth curve, man. I talk to pilots, we talk to people doing directional drilling in the lateral. No one uses earth curve.
They do.
None of this stuff, man.
Except every World War II and World War I ship targeting system. Maybe if you discount that.
No, they don't at all. No, they don't.
Oh, can I? Okay, I'll tell you what. In fact, Britain
on the ocean spot targets, mate. Spot targets at eye level. Up to 50,
they have something called the crows. They have something called a crow's nest and radar mounted.
Dean, you think bullets are going curvy to their target? What? And you're like, idiot, what mate. Does that GPS?
You don't think bullets are curvy?
You do not think ballistics are a thing? Are you being serious?
Yeah. You think they're
holy shit!
Do you know what, Dean? You know what's really serious is the fact that you think a bullet experiences Earth rotation underneath it. That's what it shows you. Dishonesty. It shows you dishonesty.
You don't trust.
It shows you how stupid you are to keep pushing the same line.
No, but Dean, you think the bullet maintains the same level, like over Earth curve as it's traveling? Let's say long distances. You believe, or does it drop, get closer to the Earth? How does it work?
It takes a ballistic flight, so if you aim it up, it goes up. But no,
you
divvies think. It doesn't think. Oh, I'm going to stick to the curve of the Earth.
No, I'm asking because it's your nonsense, so I'm wondering.
Range,
no, it does not stick to a curve of the Earth.
Is it like the light ray? Does it stay concentric with Earth?
You're a pair of idiots, mate.
The light ray doesn't stay concentric with Earth. It would under very specific circumstances.
No, it doesn't. Mind of God, why have you got this obsession?
I'm talking about the cables.
Hold on. Mind of God, why do you keep on saying this? Every time we talk about light bends, you keep on saying it's got to bend exactly with the curvature of light can bend in all sorts of angles, all sorts of curvature. Why do you keep saying it only can bend?
Hey, Rumpus. When you say bend, let's be clear. Let's clarify some things here. At the angle of incidence is where it bends. It's not actually bending. It's just changing direction at the angle of incidence. Let's clarify that, please.
In the atmosphere, a ray of light bends in a curve.
It changes its direction based on the angle of its incidence.
There's no such thing as angle of incidence. It's just curves.
But wait. To answer Rumpus's question is that Black Swan, it's the most damaging because you guys believe when those K = 1 value that along its ray path that it's moving concentric with Earth, and that's the part that's ridiculous. That's why I keep referencing.
Okay, mind of God, for that particular example, the bending of the light is close. It's not quite the same, but it's close to the curvature of the Earth. That is correct. In that one particular
Rumpus, it's the angle of incidence. That's the only time it changes its direction.
Not relevant.
Wait a second. Prior you said that there was no such thing as angle of incidence. Why would you say that? Why would you say that there was no such thing?
Yeah, one at a time, guys.
Why would you say?
Right, I've took them all off mute. Put them all on mute for just a minute till they all calm down. Try and get a bit of one-on-one going, or two-on-one for a minute maybe. They'll realise in a minute that I've muted them. Quite funny, actually.
Between two different mediums. In the atmosphere, we don't have two different mediums. The angle of incidence stuff is only relevant to Snell's law, which is not relevant to the bending of light in the atmosphere.
Mind God, I've got a quick question for you if I can.
Dean, what's up, bro? You want to talk about something spiritual, like what's going on in the world?
Did you just lie, Rumpus? Did you just lie?
All right,
Rumpus, you just
I
lied
actually
to
would,
everybody.
believe it or not.
Yeah, that's fine.
But that's for another conversation, not this arena.
No, FED, man, you got to chill out, man. Like, just what are you asking?
No, I was
I'm
asking.
not asking nothing, dude. I'm telling Rumpus he's lying by saying that the angle of incidence has nothing to do with Snell's law. That's how light bends.
No, I didn't say that, you moron. You didn't listen, did you?
Go back
Snell's
and listen
law
to the
is
audio.
about where you've got a medium change, and in the atmosphere there is no medium change. I can show you the diagram if you like. Snell's law only applies.
Light doesn't bend; it just changes its angle of direction.
Just don't listen, or you're too
Listen.
You're a moron.
The fastest path light travels is in a straight path. When you get refraction, you get refraction because light is changing its angle of incidence.
You're talking about
the light is changing its direction.
Is not relevant in the atmosphere, you moron. Snell's law only applies when you've got two different mediums.
Tapping.
FED, man. Do you know who's tapping?
No, that's me. Sorry.
It's not me.
Sorry, I thought I was on mute. Sorry.
But FED, their main weakness is the atmosphere assumption, not the mathematics of the ray path.
No, they're telling you that light is bending, physically bending. It's not. It's changing the angle of incidence. It's changing its direction. But it's not
rays do not exist in reality.
It's just changing its direction.
Flat Earth data.
Something that they use on video games.
Flat Earth data, just really quickly. Now, just really quickly, Flat Earth data. If I concede and say that light changes direction, and it changes direction very gradually over time and over length, could I classify that as a bend, do you think?
So if you want to look at every orthographic drawing of refraction and anything, you always have to have a normal. And it's always on a plane surface. Now, the entire surface is not necessarily smooth on water, but for the most part, you're going to have a normal.
No idea.
Do you understand? That's how you measure the degree of angle.
So wait a minute, stop. So the normal is, like you say, and angle of incidence is about boundary of refraction in Snell's law. The problem is there is no boundary in the atmosphere, but there are density changes, and it's graduated. So you have to look at more complex things.
Yes, and Fermat's principle states that light will travel in its the quickest path, right? Which is a straight path. The only time it changes is when it's passing through the only time it changes.
They're arguing about a lot of stuff you don't need to argue about.
The only time it changes direction is when it goes through a different medium.
It has nothing to do. This has nothing to do with the horizon. Nothing to do with the horizon. I have a question for you, Rumpus. I have a question for you. You're trying to stop me, Rumpus, because you know what's coming, isn't it? You know what's coming. You're not arguing about refraction.
We're talking about black swan.
I'm talking to flat Earth.
Why are you talking about refraction for then?
I'm talking to flat Earth data. Right.
You're talking to me there, Rumpus. You're talking to me there, Rumpus.
Brian,
I have a question for you, Rumpus. I have a question that will end this now. I'll end this right now. I have a question that will end this right now. I'll end it right now. Can we see the geometric horizon that you're stating is there? Can we ever see this physical geometric horizon? Can we ever see this physical geometric horizon? Can we ever see the physical geometric horizon?
I think we could have a conversation as well as this carrying on, believe it or not.
I'm up for that, Dean.
That'll be interesting, won't it?
Yeah, seriously. What I'd like to do,
have you done any other songs?
Yeah, a couple of bits. Actually.
Rumpus, just shut up.
Oh, wait a minute. Volume's a bit of a problem.
Rumpus, just say hold on and everybody will
want
stop.
to deal with flat Earth data's claim that
Is he still going?
We do.
Right. The
We do.
Light only travels in straight lines. It takes the fastest route, but in a medium that is varying in density.
Rumpus, you know that repetitive, when you repeat yourself like that, it's a clear sign of mental illness.
Yeah,
you know
you're
that,
more.
don't you?
You're not qualified
it's a clear sign of mental illness. It's a clear sign of mental illness. It's a clear sign of mental illness. It's a clear sign of...
That's not, yeah, that's...
Light are just radio frequencies.
So,
can I test your model, Rumpus, please? Can I test your model in a real life scenario? You know, your lighthouse one, because I've been wanting to for ages, for about an hour.
Okay.
I just want to put in a real life scenario, just basic as basic, using my human eye, looking out over a sea, and I've got a 6-foot person who can walk on water. Jesus, let's pretend. Just as a thought experiment. Jesus doesn't need to exist in your atheist.
Just a quick shout out to Paul Russon for the super chat. Cheers, mate. Hold on, I'll give you the wrench. No problem.
Rumpus just left. I don't know if you're addressing this to him.
But anyway, let me address it without him interrupting, because that would be brilliant, actually.
Yeah,
thanks, Rumpus.
Come back in. Wait a minute. If you're asking him to do it, it's going to be hard if he can't hear you.
No, look, everybody has got that diagram imprinted into their mind. So come on, just close your eyes and just go, hold on, and you'll picture it back. Yeah. But anyway, so he's got put it this way, let me come straight to the point. I've got my human eye and I'm watching a 6-foot person, the same height as I, go off into the horizon. Yep. Okay, the ultimate question was, would that 6-foot object / person disappear because of either A, Earth curve, or B, perspective first?
C, diffraction limit.
I was going to remove all refraction from the... And
no,
just
but I mean,
but
so
we can go with diffraction.
Wait a minute, we're looking with our eyes then?
Yes, just eyes. Just eyes. We're going to go basic.
No, yeah, they'll disappear.
That's a great question, Gleem.
Okay. So on his diagram, that would not be the case. It would be purely geometric, and it would be purely disappearing, just like the geometric version on Metabunk.
Absolutely, yes.
Yep. So therefore, his diagram doesn't represent reality, even with
stop. Wait a minute. If using human beings of 6 foot tall, that diagram is absolute bollocks. Yes, because it's an object that you cannot see beyond where we would say there's physical obstruction. But turn that into a fucking boat. Turn it into a massive, a 300-foot lighthouse, and the angular size is still there at the distance that it is hidden. Then
yeah, but Dean,
that's what that diagram is
if
for.
you have a 100-foot boat, all I'd have to do is square root the distance of it and times it by 1.17 to get the distance, how far away I am from the horizon. Either I'm a boat, looking at knowing the distance to a lighthouse and using that quick calculation. No Earth curve needed, bro. That 1.17 is from the Airy's diffraction limit experiment, meaning the calculation of light through radiance. They come up with 1.17.
I'm still waiting for you to tell me this simple question. How does perspective occlude something? So in your hallway example,
wonderful.
What is going to get hidden in the hallway?
Let's talk about the hallway. Exactly. Yep. Let's talk about the hallway first. Once you tell me how Earth curve is causing the apparent junction, explain to me how physical-bodied Earth would appear to make the clouds and ground touch first, and then we'll go to the hallway.
The grounds are much further behind the physical obstruction.
Okay, so as the clouds move away from you, they don't reduce in angular size?
They absolutely do, yes.
Awesome. So one of the synonyms of perspective is angular, right? Do you think there's any correlation to perspective and angular size of things?
Do you know what the perspective calculation is and what it deals with?
I just asked you a question, bud. Answer it.
Sorry, what was the question again?
I said, as things move away from you, actually, I can't, what did I just say? I just said something about when objects move away from you, you're claiming that's responsible for the physical Earth curve and perspective is not responsible for it, right?
I am saying.
But you just agreed, agreed that as the clouds move away from you, they do reduce in angular size. So if they do reduce in angular size, are they reducing in angular size because of, are you reducing in angular size because of Earth curve or because of our eye and the distance to the object?
Nothing to do with our eye.
They will be occluded before. They will be occluded before they can reduce angular size enough to be able to not be.
Carlos, spell occluded. Spell occluded. Spell the word occluded.
So listen,
flat Earth data.
7-11.
Listen, you just admitted that clouds would move away from you would reduce in angular size, right?
Yes.
That has nothing to do with physical Earth curve, correct?
Correct.
It's just the distance to the object, right?
Correct.
Just the eye has 1/1000th degree resolution, which is based on what? Do you know? I know.
Say that again. The eye is what?
The eye has a 1/1000th degree of resolution. That's how much detail it can see at certain distances, and based on the size of the object. Okay.
Yeah, rods and cones, but that's based on people's perception as well.
It's based on one constant formula that's in all limited diffraction systems. The derivative is 0.000112. When you times it by 57.30, you get 0.007 degrees. You can take this, times it by 3.14 divided by 180, and then times whatever, how far away the distance to an object is, and it will give you the diffraction limit of it. Okay.
Just really quickly, so that we're clear on this.
So listen.
Wait a minute.
Listen. As objects move away from you, they will reduce in resolution and in angle size based on the size of our aperture. Okay. This is the fundamental reason why perspective happens. This is why when you look down a hallway, Dean.
Correct.
This is when you would look down a hallway, Dean.
Perspective has nothing to do with aperture.
This is when you look down a hallway, Dean, knowing that the hallway is constructed of rectangular plane pieces. You'll see a geometric constant. There'll be a divide. There'll be 30% above the center of vanishing point and 30% below, based on.
Shout out to Ocean's Level for the $5 super sticker. Thank you very much. Indeed, a mic drop moment.
Separated by the horizontal. Okay?
Cool story, bro.
This is fact, bro. This is your eye and what it does. So listen.
Cool story, bro.
This apparent convergence that you see.
Oh my God, you are a Poe, and that's why it's flat Earth data. It's fed. I've got it now.
Don't do some research on how your eyes work, mate.
You're a very eloquent moron.
So again,
Carlos, you don't need to say that to Dean. He's on your team, bro.
A monkey you can put a round peg in a round hole, mate.
So here's a question, flat Earth data. Can you tell me what diffraction is?
The resolvable detail of the angle of a light. You can do it with between one object or two objects. It's the resolvable detail of an object.
Can you tell me?
So I just gave you a formula. Listen, it's the resolvable detail of light based on its angle.
What are the components to it?
What are it's the wavelength of light that you're seeing.
Right, wavelength. Brilliant. Does visible wavelength in the color spectrum have different wavelengths? Yes or no?
You have a visual spectrum of between what, 400 and 700?
Right, from red, green, and blue. Brilliant. Now, wait a minute. Do you know what a visual artifact of aperture diffraction is? Yes or no?
A visual artifact? It depends on what you mean by a visual artifact. It could be lens related. It could be aperture related.
When we look, no. It's definitely diffraction, as in the edges of that aperture based on the wavelength. But visually, how do I determine that? If I've taken the camera and I think, oh shit, too much diffraction, what is the actual visual term for that?
What the actual visual?
Yeah, I can see it visually. We can all see it visually. What do you think it's called?
Well, it would depend on the size of your aperture. What do you mean? What is it called?
It's called chromatic aberration. It's the separation of red, green, and blue. Point to me in these observations the split and fringing of red, green, and blue.
Wonderful. So you're acknowledging that the eye has limitations to the wavelength of light. Fantastic. You also conclude that it has a diffraction limit of 1.22. Do you agree?
Fucking hell, you're concluding everything for me and making me agree. So just have an argument with yourself. Go for it. You might win.
Yeah, buddy, I'm asking you to clarify. I'm asking you to clarify. You just brought up the aberration. The aberration is a distraction. At the end of the day, dude, you just acknowledged that the human eye has a limitation of you just acknowledged the human eye. You just acknowledged that the human eye has limitations to visible light. Can I see farther? If I had 200 nanometers, could I see farther? Could I see farther through the atmosphere? So if I took my camera and put a violet filter on it, I could see farther, right? Right, Dean? You little peckerhead.
Oh my God. Are you sure you're religious? You seem way too angry and devil.
I don't have to like you. I don't have to. I have contempt for liars and dishonest people. You're a peckerhead. You're one of those guys that walk around with a big pecker on their head. You just walk around with a big pecker on your head.
And treat us with respect and save us and treat the, you know.
Look at you. Now you turn it into a religious argument.
That's not what we're supposed to do.
Is it not?
Dean, we're supposed
I'm
to
supposed to call you out, dude. I'm here to expose your fallacies.
You with respect when you've come here to ridicule us. You fucking.
I haven't come here to.
Dean, we're supposed to expose you guys.
Shit. I can have serious conversations with people that aren't shouting, and I don't mind that.
Right, occlusion then, Dean.
I just want to answer your question, why we're doing this. It's not to save you or get you on our team. It's to expose you in front of other people. 135 people watching, shout out.
Should we go through the occlusion?
That's exactly why I'm here.
Wait a minute. Let me just ask. Find got a question. It just came back to me then because it just spoke, and I've got a question. Because
but Dean, one point though, why do you keep monologuing about all these optical terms? We're trying to get you down to declare something practical that people can do.
Okay, right, so the very important reason why, if diffraction was a thing, it has a telltale visual artifact. It's called chromatic aberration because red, green, and blue separate differently, and we get fringed red, green, and blue. It used to be a problem with cameras. It used to be a lens artifact. It is how the diffraction works at the edge ring of an aperture, and it does show up visually. But
okay. Now,
I had a question for you, though. Oh, okay.
No, but with that being said, tie that to what that had anything to do with this whole debate or anything practical besides just reading that. You're saying the aperture diffraction as a reason why something disappears from the bottom up, and that's just not
no.
true.
What I'm saying to you is that the refractive index of the eye causes the ground to rise up into the center focal point position because we have a lens and because we have an aperture. It's a combination. So when you look down a hallway, you have the refractive index of the light bending into the eyeball, passing through the cornea of the eye. It causes things to converge. It's called vanishing lines, convergence. It's an actual place on the retina where lines converge and cause a vanishing point, bruh. That's why when you look at anything, you have to focus in on the center focal point position.
Dean, you just gotta watch Life is Short's videos and just be humble, man. Admit that he's running circles around.
You're being disingenuous. So listen, here's an
let me just ask. I've got a question. I've been waiting to ask this question for ages. My God, I heard you in a thing on Ranty about 2 days ago. I just want to ask. It's a very short series of questions. Do we agree that it's nothing to let's say it's a flat surface, wouldn't give a shit, or a globe, couldn't care. Can we say that? Based on our understanding of refraction, light bends towards the denser medium, yes or no?
Sure. Yeah. I don't know too much about. Yeah. I'm sure that's the way it works. When a ray experiences a different density, then it changes direction. That's the way I sort of.
Yeah, so Snell's law, like actually Flat Earth Data pointed out, is about angle of incidence and the normal direction of that new change, and it always bends in the denser medium towards it. So in our atmosphere, is it fair to say that, because the air is denser at the ground, because we've got 14.7 psi, we've got a lot more air, we've got a lot more of the atmosphere here than higher up. So we can say that there's a graduated density. That's not in contention, is it?
No issues with that.
Right.
I just want to make sure you're applying. 1 second. I just want to make sure you're applying that gradient at every point along this curved surface. That's correct, right?
Curve or flat? Don't care at this point. Curve or flat? Don't care.
I just want to make sure because you guys are using that profile to steer these rays in that black swan image when the K value is 1. So that 1 second. That assumption, you're at the mercy of that assumption to allow these rays to steer infinite over 6. I know that that's just a term that you guys use, but what that means for people out there, that means that ray is constantly changing direction. It has the ability to stay concentric with Earth curve over a long distance. So it's whatever, infinite over 6. It can constantly change direction. The only way a ray can change direction is if, like you just said, it experiences a different density. So what is creating that steering close to the Earth's surface when, like you were saying, the density is the same? There is no gradient. Right, along the surface over 20 miles, 10 miles, there is no gradient.
So I heard actually on this. Okay, I'll answer that, but then I'll carry on with my 2 questions.
Yeah.
Because this is actually good. So kudos to Ranty on this one for taking Fight the Flat Earth to task and actually making both Fight the Flat Earth and Team Skeptic, who I think it was Team Skeptic, say something utterly fucking ridiculous.
Everything they said was ridiculous.
No. This was particularly ridiculous. Okay. They said in a graduated atmosphere, if you look along the same density line, then it would just be near enough straight, and that is absolutely false. Light bends towards a denser medium, and in a graduated sense, there is always density below it greater than there is above. So there is no situation in either reality on any geometric shape where light would not bend towards a denser medium, and that you could even fire a laser up in the air and it will bend round, and once it gets to that homogeneous zone, it won't stop bending, because the bending of light is about the
Dean, you just said RF signals can shoot straight out 12,000 miles. Now we're talking about light bending over as little as 3, 4, 5 miles. What? We're talking about what?
Well, wait, FED.
Where are these straight lines? Where are these straight lines? Where are these straight lines then, bro?
Let us finish this, man. Dean, just to word this in a different way for people who maybe don't know as much, you're saying along the interface, even if there is no sort of density gradient, it's still constantly going to bend towards the denser one.
No,
right?
what I'm saying is in that density gradient, let's say we've got a graduated sense, which is from, let's say, 100 on the ground to 0 high up.
Okay.
If we are at 90, it's going to bend downward, and we're firing dead. Dead in that band of 90. It's still going to bend down.
Fair enough. So even in the interface, even in the layer of, quote, constant density, it's going to honor its surroundings, right? Just to word it friendly.
That's purely because it's graduated and the electrons below it are denser than the ones above, and it's that simple.
Sure. So now let's apply that logic with this curved density profile with the black swan, and you'll see that you can't have a situation like that where rays along the surface of the Earth stay concentric, for that long.
So here's the thing. I'm going to say something a bit weird and probably not liked by my side. I agree that is a black swan, but upon the condition that the statement is as follows. In photography across water, the world always presents itself as a planet, as in curvature. Then yes, that is absolutely a black swan.
Question for you: if the black swan photograph was shot with a filter, an infrared filter, how much farther do you think it would see? Apparently there's a 10-mile horizon there for an 8-foot observer, when technically, based on the spherical geometry of the Earth, it would be at 5 miles for an 8-foot observer. But this one you can see way farther than that.
FED, let him finish. He was about to concede. Yeah. He was about to make a little bit of a concession. Just let him finish his point, and then.
Well, no, I did concede that if the statement is this, in every photo we see curvature on the horizon, then that is absolutely a black swan, because we do not. We actually do. Well, all right, I tell a lie.
There you go. So
we see. Wait a minute. Listen to this. We actually see, and I've modelled this. We actually see upward curvature in the black swan.
Sure, I don't buy what you and Ruhif are saying about that.
So Dean,
but that's fine.
Dean,
but wait a minute.
A question for you. So you don't believe in the refractive? You don't believe in the refractive index? You don't believe in the refractive index of the human eye, right? Staring down a hallway. You don't think it rises up because our eye has a lens?
That the density of our eye and the lens on it is different to the atmosphere. Therefore, there is a density change, and there is an IOR value in our eye. Yes.
When objects move away from you, they reduce in angular size, and that's based on our perspective, right?
Yes, that is to do with not our perspective.
So when we look down a hallway, when we look at hallway, the doors, all the lights, all the things, they get smaller in size due to perspective, but they converge at a point, right?
If it went on far enough, possibly, yes.
But it converges. No, you've never seen a hallway converge at the end in photographs? You've never seen that?
Not possibly. It does.
Well, no, I've seen it, but I'm saying you would have to have a long corridor.
So just to clarify, you're not claiming that our eye is responsible for that. You're claiming that the hallway does it?
No, I'm saying that's a function of perspective.
That is a function of perspective, which is basically due to distance to angles, right? Objects, right?
Yes, that's to do with distance and angles, yes.
Yeah, so what is the changing at the when you look at the apparent horizon? Tell me how it changes. Your angles are just larger now at this point, are they not?
What do you mean, what changes?
When you're in a hallway, the convergence point happens quite a bit quicker than 3 miles. The vanishing point in your vision happens a lot quicker than 3 miles. And I would conclude that to be the size of your limit to the angle sizes. The smaller the angles, the faster the convergence or the apparent vanishing line.
If you took
if you have more obtuse angles and a larger vision, you would be able to see farther before the convergence would happen because you are limited to angles. Are you not? The eye is an aperture. The eye is an aperture. A camera is limited to angles. Give me an example. If the refraction index wasn't happening on the eye, why does it happen on a lens? When I zoom in on an object, I reduce my focal width by compressing my refraction and limiting my angle, but I'm compressing the image forward into my eye.
Dean, do you actually disagree? Do you actually disagree with what he's saying, or?
I think he's monologuing, and I don't think you compress refraction.
Is, man. I don't even understand his point.
No, I don't.
The point is, he ignores the fact that the eye has a refractive index, which causes stuff to rise in the center focal point position.
Let me tell you something.
That's a byproduct. The convergence point of the human eye, or vanishing line of the human eye.
I'm not trying to take away from your enthusiasm, but it's not that strong of a point because from our
are you kidding me? It's all about vision. It's all about vision. And if this guy, his argument.
Let me finish my point, man. Let me finish my point. When we're talking about those kind of distances, the curve and the flatness are effectively the same. So we're not even really debating geometry at that point. You're sitting here debating definitions of words and what do you label what.
No, I'm debating angles of light to the human eye and what the interpretation of it is. Get that straight.
Right.
The fact is their interpretation. Their interpretation of the angle of eye is curvature. That's why I'm documenting it.
Right.
When in the same breath, I asked them in the same breath.
From 1 foot
exactly. In the same breath,
miles.
They all claim that the comparent junction of the sky is Earth curve, and then ignore perspective, and some of them say neither. So absolutely, it's a strong point because everybody who I've talked about it so far and to this point are absolutely debunked by it.
But
so it's 100%.
The only reason I have issues with that is you're breaking it down to something that he obviously agrees is a real thing. So when he says it's Earth curve, he's just saying that almost to troll. It's not like he thinks that that's the only thing that's governing.
You're divining his thoughts. My job here is to get liars, bro, and now you're defining his magical thoughts.
Well, okay, let me clear. Dean, do you actually think Earth curve is the only exhaustive variable involved in what you see over long distances, like the horizon?
As in the geometric horizon? No, that is not the only thing. No,
of course not, because we've already debunked that doesn't even work with the black swan.
Can I say something? There is a reason they keep changing and correcting the curvature calculators, like Walter Bislins is correcting it. What is the other? McQuest 3 times in 2 years, because they try to match the reality for the globe groupies and globe fanatics, so they can have a tool. But with black swans and apparent horizon, we destroy them totally. So I'm sure they have hundreds of people working on this problem right now.
Yeah, it's true. That might even be why we're in lockdown, because there's so much pressure. They need all the hands on that.
Just really quickly, can I finish my question?
Flatten the curve, please. Flatten the curve.
But 1 second, FED, I don't want to get away from your thing, but I think language that Dean can understand, and I'm sure you can too, is when you ask somebody what is that, a better thing to say is what variables, if you were to model that, would you take into account? So obviously Dean's going to say Earth curve because he's a ball earther, but he obviously is not going to disagree that it's distance. It's like the observation height, which implies an angle, and all those atmosphere and all that. So
here's the main difference. Here's the main difference, though. Right to hand. Is this mind to God or right to hand?
Yeah, mind to God. Yep.
So listen, mind to God. Correct. The difference here is that you're sitting talking about a 6-foot observer trying to calculate dip over a distance of 10 miles or 20 miles or 5 miles. Yeah. Meanwhile, we all can get in a helicopter or a fucking plane and fly around that 5 miles, and there's no fucking curvature to be found.
Right.
The point is that these guys are just relentless in their asinine and double speak. It's just like I'm just here to fucking get these guys, man.
No,
and just
I'm not,
put
I'm
them
not
all
saying
together.
You don't understand it. I just think for the person listening who maybe doesn't know the nuances of all what the argument is, because you already know the argument before you're saying it, but people out there maybe don't quite get what exactly you two are debating. I don't fully know, but
can I try do it with diagrams? Yeah. Sorry, can I try and do it with diagrams?
Can I just finish asking Mind of God my question, because it was something about a show two nights ago, I think it was.
But wait, Dean, for the record, our first little conversation, you said that black swan is truly an optical anomaly that does stress out the ball Earth model. Would you say that? I know you don't think it disproves it, but it stresses it out, right?
It doesn't stress it out. It actually presents as being a little bit concave.
Okay, well, I mean, that's not good, but okay, fair enough.
Shout out Jason McCormick.
All right, so Dean, sorry.
I'm not saying it is concave. I'm saying it optically presents as being concave.
That's actually more stressful. It's actually flattening it and then doing it more. But I don't want to put words in your mouth. But fair enough. Go for it.
Okay.
No. So my question. Wait a minute. Just really quickly. My question to Mind of God. After we talked about that light thing, and after now, I'm eventually going to ask this question. Is I actually heard both you and Ranty say something, and I think it might have been. Oh yeah, no, it was Rumpus that you were arguing with, surprisingly enough. But okay, so we've got a ray of light that bends downwards, and we've got so we know that light bends downwards. Yeah. Now let's forget about a single ray of light. Light is emitted from everywhere in every direction on a surface.
Yes, I'm okay with that.
Okay, awesome. So now we've got an observer, and light is bending down towards that observer. Is the object that they are looking at higher or lower optically because of it?
But are you talking about the black swan or just the general ray tracing?
General. This isn't ray tracing. This is just standard atmospheric refraction. This is just refraction through atmosphere, bending down due to the graduated atmosphere. Is an object that I'm looking at over distance, it doesn't matter, pick any distance, but if the light is bending down, is that object that I'm looking at apparently higher in my vision or lower in my vision than it actually is?
I can't answer that until we define what the channel is, whether the Earth is curved and what the channel is. That's the whole thing that I'm
Let's say it's flat.
Okay, it's flat, and then the density profile is the same as you talked about.
Yeah, and the light's going to be bending down. Is that object higher or lower?
So the light is bending down. I mean, it would be higher.
It would be higher, yes.
Right. Are you trying to quiz me, or are you trying to?
No. It's just that when I saw an example of I think it was you, Paige, and Ranty.
Yeah.
And Rumpus was drawing a line from his fucking lighthouse, which he always has.
Yeah, but Dean, just to clarify, I already we know Rumpus goes from right to left. We were going left to right, so just I know what you're talking about. That sugar chamber with the flat strata.
Just the lighthouse. The lighthouse was on the left, and he was trying to draw a line from it. But then he started drawing more lines, and you had a problem with him drawing lines that went up. But he should have drawn a quintillion lines bursting out in every single direction, because that's how light works off an object. And it's only the ones that are fired upwards that bend round our geometry, let's now say it's a sphere, and come down, and they cause the apparentness of that object to rise up.
Yeah, but that's a fair point, where yes, light will then hit every point on that object, right, and then kind of emanate in all directions, right? We're cool with that. The issue that we have is, if you're familiar like with statistics, the object at the bottom, there are situations where those rays, not every single one, fair enough, but a good cluster of them will not make it to the observer because of the angle. And then let's just say light does bend down.
Just really quickly, the only ones that make it to the observer are the ones that make it to the observer. And I can pretty much guarantee you that they will be less than a quintillionth of the ones that left the object. However, all of that object, if because light is bouncing everywhere and because it's bending downward, all of them that represent that object.
Yeah, those are just words.
We'll go
I'm not trying to be rude, but those are just words. Because
everything's just words. That's how we communicate.
Well, you can't verbally guarantee me that all the rays that hit the base of an object just because Dean said so. So you go to the rays that hit the base of
all the ones that hit my eye.
One second. You go to the rays on the base of every single object on Earth and tell them to make it to the observer. You say Dean said go to the observer, so go. No, you don't think there's atmosphere situations where not just the base, but maybe a significant portion of the base will not make it. You know, they will just, like you said, curve down and die into the water.
Right.
Or the ground
So the problem is this, and this is the point that I was trying to get to.
Okay.
The ray, let's say that ray that left and curves down and hits the water, or let's say it curves down and hits the guy's or girl's nose. It's not making it to their eye, so it's not made it. Now, and that was fired out at 40. Let's say 90 degrees perpendicular to it. Okay, so now let's take the ray a fraction of a degree up from that. Guess what? That hit the observer's eye.
Yeah, that's fine. We're talking
which
about
means
bottom up.
he saw, or she saw, sorry, they saw that portion. It might have emitted rays in every single direction. One of them made it to the eye. Even if some don't, some fired out left and right, some hit the ground, all over the place. But the ones that fired slightly upwards bent round and hit that person's eye and caused the object to appear at the angle that the light came into their eye.
Let me test how honest you are now. The bundle of rays that are leaving the top of a lighthouse to the bottom, which one have a statistical preference to get to the observer? The top, obviously, right? Because of the elevation. Do you agree with that? Statistically.
It depends. It depends.
No, it never depends. It always has a preference. Always.
No.
Always.
The only preference I would say.
There'll be no condition where the cluster of rays leaving the top would ever have a worse chance than the bottom. What atmosphere would do that? You have to propose that. That's impossible. Even according to your density gradient, it would never do that.
He done the opposite.
You know what?
One second, let him answer. Let's see how honest he is. Let me see how honest he is.
So the only thing, statistically, the thing that I'd be worried about, given that nothing's moving in front of it, is light attenuation.
Sure.
The top of that object.
Let's say all that is uniform.
The top of that object is further away from me than the bottom. So when you say statistic,
you can't say that now, man. But let's assume flat Pythagorean theorem says the distance is roughly the same. You can't play that game that the top is slightly further than and bring that into account now. Let's assume it's far enough away where that's far for you.
No refraction conditions whatsoever. Just I'm actually in a homogeneous.
No, it's that same atmosphere that you guys just made. That density gradient that you constructed. That's the atmosphere.
Then if there is no if there's no effects like mirage effects or lumen,
exactly. Not yet. None of that.
And the profile curve is perfect for that refraction.
Yeah.
Then all of that I will see it, and that's just the way it is. All of it I would see. I'd see it slightly higher, but I'd see all of it.
You can't even say that because just look at the exposure to that top element on that lighthouse. Rays will be emanating from that in a larger, I don't know how to, like a circumference, you know, like if you look at the bottom, this is the reason why bottom up happens fundamentally.
I like this Gleem, by the way. I did like that previous diagram.
Do you understand? The bottom does not have as many rays leaving it, quote, leaving it as the top. That's the first issue. And then the second issue is
wait a minute. So you're saying the surface area of the bottom is tinier than the top?
Well, you just said rays will emanate from each point along that tower, right?
Every single point equal it in every single direction, yes.
So if you were to put a circle around the top and the bottom, which has a greater volume of rays emanating out from that? Like think of like Gauss's law.
It's based on surface area.
Right. So the top has more rays emanating from it. So it gives you a better chance.
Yeah, but if we divided it by half, both the top and bottom have equal surface areas. That's how we did it. So then it's equal.
No, the bottom is against the ground. It has the base. Half of those rays are not. There's not a high. There's a higher concentration of rays that have access to the top than the bottom of an object because the bottom is against the ground. That's the whole point.
Wait a minute, man of God. We see light reflected from the object, correct?
I'm not talking about the observer yet. I'm strictly talking about rays from the sun hitting an object, the top and the bottom. the cluster or density of rays.
Let's take the sun out of this. Let's just go with ambient light.
Let me finish my statement. The rays that are going to interact with the top and the bottom, do you agree that the cluster, the concentration will be higher hitting the top than the bottom? And then going to the observer?
No.
It has to.
It absolutely doesn't. If you could draw me a diagram where that proves true, then absolutely
why do I need to draw you a diagram? The ground is there.
Yeah, and it's not covering up the object at all. So
no, but where the bottom half of that circle that I would draw along the point, the very, very point where that tower hits the ground, if you were to draw a circle around that, what's the bottom half of that? That's the Earth.
Mind the God, think about it this way. Let's turn that into a block. Let's turn that into a building that's a square, and let's get rid of all the sides except the one side that faces the sun, and let's put a dividing line exactly halfway up. Now, from the point of view of the illumination of the sun, what gets more light? Regardless of whether there's a ground there, it's both equally.
Yeah. I'm okay with that assumption.
So now when they're emitting off, since the light that we see is just a reflection, the equal amounts of light that hit that reflect away from it.
Yeah, and the concentration's higher on the top because it doesn't have the concentration higher.
Okay, listen, I have a question. So I've been listening to this. So essentially, what you're saying is that if you imagine all these lights emanating from an object, essentially you can imagine them like a jigsaw puzzle, right? So they're a jigsaw puzzle at one side. Then you dismantle a jigsaw puzzle. You throw all the puzzles up in the air, and as it lands back at your eyeball, it somehow miraculously reforms itself in a perfect jigsaw completed puzzle every single time. Is that what you're saying?
Absolutely not, no.
Me or Dean?
Well, I think it's not about me.
Dean, yeah.
No.
Then how do we see every single time we go out and we see across the shore and we see the buildings across the way, every single time, right? We always see them in their perfect forms.
Yes.
Why? How?
Well, what's your distance there?
It doesn't matter.
Well, my example is this. If you're looking at it 69 miles away, light would only have to bend 1 degree from there to get to your eye.
Well, I'm not talking...
To match the curvature of the planet, and it would only have to do that uniformly and present itself as if it's flat or concave, like the Black Swan image you claim.
So, yeah, so uniform every time, right? How is it when
it won't be uniform every time. It'll be wavy in some cases. It depends on atmospherics of the day.
Okay, so how come when I can go down to film where I film in Blackpool, I can film Blackpool Tower every single day, and there's never a single pixel difference on any of it, or every beam's in its correct position, and then I can turn around and I can look at Barrow in Furness, and I can look at the buildings over there, and all the buildings are all symmetrical in every shape and form. They're all lined up next to each other. The windows are in the exact same position, and this is every single time. And you're going to tell me that these lights, that the light is traveling and scattering and going off in all different directions, and then being pulled back down into my eyeball to form this.
I think you've missed what I was saying there, Ranty.
No.
Oh, yeah,
Ranty, wait. Can I finish my point? 1 second. Let me finish.
1 degree over 69 miles,
and you guys
almost
can take over.
3,000 feet of physical
I
1 second.
I think what you're...
Can I finish my point, and then you guys can take over? But dude,
okay,
simple thought experiment. We have the sun, the light source, then we have a building. Picture now we'll go in Muppet vision. Picture the side of a really tall building, okay? And then an observer somewhere over to the left. So now we draw a circle on the top corner of the building, and then a circle down at the bottom. Like side view.
Oh, right. So kind of architectural design.
Yeah,
what
the way you guys always
do. For that kind of stuff. Yeah.
Yeah, so you see that? So we have the face of a building. You drew a circle at the top corner and then a circle at the bottom where the ground intersects the building.
I don't actually get what you're on about a circle, though.
Just draw a circle in your mind. Okay? So
can we just divide the object with a dividing line exactly halfway up?
Well, no, the circle is just to define 2 points that are being illuminated. The point that hits the ground and then the point that's the very top corner of the building. Just to highlight that. Okay.
Yeah, honestly, I'm really sorry. It is late over here, but I don't quite fully. I'm finding it hard to follow your visual example.
Wait, Dean, are you doing this on purpose, or are you seriously?
No, I promise you, I'm not.
Looking for a toilet roll. There we go.
Come on, dude. The concentration of rays that are leaving the top building point of the building versus the bottom, the base, is higher on the top. That's what we prove with Rumpus in that example. So your point is fair that there are more than just that one ray that we were playing around with, but the concentration of the rays at the top, some will shoot off to the top, some will shoot sideways, and some will shoot down. They have a higher statistical likelihood of being illuminated strictly because of their height. And so if you do that same experiment down at the bottom, okay, I get your point. Some of them may make it. I actually appreciate your point, and it's true. But there's a large cluster.
No, seriously, my God. My statement is exactly this. The amount of light emanating it will be based off surface area and the reflectance angle. Now, if the angle is uniform, that's why I say pick a flat surface. So let's say it's a block of flats or something, not a round surface. So now it's a block of flats. That entire surface will be uniformly lit, which means
I'm trying to tell you that's not the case.
Then you would see shading on it. You'd be able to walk up to that building, look at the top of it, and it'd be lighter than it would be at the bottom in direct sunlight, and that is not the case.
We're talking about visibility. First off, no, we're not talking about scale. Like
visibility, correct.
Yeah, right.
Light reflecting off an object, how we see it. Yes, correct.
Okay, so the top, there is more contrast, and that is true. If you have the top of a building and it has more height than the base.
I'll tell you what. Show me a building like that's out in full illumination with no shadows cast on it, and all it's sat is on the floor, and show me the side of that building where the bottom half of it is darker than the top, and you might have a point.
That's what I'm getting at, is we've shown that. That's the whole point.
All right.
It's not that it's darker.
What do I search from? Google Images.
No, it's the obstruction bottom up. This is the motivation.
No, you've just said less light hits it at the top than it does at the bottom. So I'm
saying the concentration of rays that are leaving the top make it more statistically likely to be illuminated.
Yeah, and I'm trying to ask you, why are more leaving the top than the bottom, and you're not providing with a mechanism for that.
If you draw a circle around that point, consider the rays leaving that, the concentration of rays leaving that circle is higher at the top than the bottom because the ground is there.
Right. So are you saying that the ground stops rays leaving downward, or do they simply hit the ground and they are leaving in every direction? They just hit the ground.
The concentration of rays that are leaving that point to illuminate it at the observer is always lower at the bottom because the earth is there, or the water. That's just basic density of light rays. It has to be.
What I'm telling you
that's why the height always
under standard atmospheric refraction, the light that is fired in the potential direction.
We're not talking about refraction yet. We haven't even traced those rays across the channel yet. I'm just talking about the rays hitting those 2 points and about to leave. And now you're going to refraction and all these other things. Like, are you doing this on purpose, or do you not understand
you'd have to prove. No, in order to progress with this, you'd have to prove to me that the bottom of objects receive less light than the top, and that simply is.
We agreed that they receive the same amount, man. You're are you slow?
Okay, so the light that bounces off. So the rays that leave, which are reflections of the light that hit them, are equal.
No, the concentration is higher on the top. That's what we were showing Rumpus, but then his shoulder hurt and he had to go to bed because his mom was calling him.
So the concentration, why? Because photons
the ground's
are
in the way.
Higher up.
The ground's in the way, man.
How does the ground come into it when the photons are bouncing off the surface?
It relative to the one at the top, it doesn't have that ground limiting the rays that can come off.
It's going to go down to the ground. If it fires, imagine this: we choose 2 points, one at the top, one a meter from the bottom, one a meter from the top, and there's 30 meters in between them. We fire 1,000 rays out, and we choose random directions of both of those.
Oh, fire 1,000 rays.
That's what's happening.
The top one always is less obstructed because it does not have the ground near it to absorb the rays. That's my point.
Now, here's the thing. I can do a model of this to show you that if I fire, let's say 1,000, obviously there's trillions, but let's say I fire 1,000 different directions from that point on both of them, the same amount will hit the ground on both of them.
No.
Wait a minute.
It
No,
depends
I'm going
on
to
how
make a
far away it
concession.
is.
Listen.
No.
I'm going to make a concession.
It's just not true.
How is it not true?
Dean, let's actually simplify this. Let's say there are 360 rays, one for each degree.
Yes.
Okay, good.
Yes.
So now we have 360 rays emanating from the top point, and then 360 rays emanating from the bottom point. There is always a preference for all those 360 rays on the top to have a better, quote, statistical chance to be seen at the observer than the bottom, always.
Now you'd have to give me a distance and a height.
We're not even there yet. We're talking about rays leaving
The
being
problem
obstructed by
the problem here is if I'm stood next to the thing, you're wrong.
Fair enough. That let's not consider that case. Fair enough.
Okay. So, but if I'm further away, then and let's say we have 4 rays firing from each.
No,
How about
360, one for every angle. Stop changing the thing.
Right, okay. So the 90-degree rays that come off those are going to fly along the ground, correct?
The 90-degree rays will go along the surface of the building.
Yeah, so 0 is straight up in this case. 90 degrees is to the right, and the opposite.
Think of it down. Yeah, let's go down.
So 90 degrees goes. Oh, wait a minute. No, anyway, 0 is up, then 90. So it's just clockwise. So 90 goes along. Now 91 degrees on both of those. Yes, the one at the bottom is going to hit the floor first.
Correct.
But the one high up is still going to hit the floor because it's pointed down.
Yeah, later at a later distance.
Yes,
agreed.
Yeah.
But now here we go. Good. Now we're making progress. The top one, because of its height, right, always has a preference to be seen visually than the bottom, always. And we're not even talking about flat or curved Earth yet.
So the issue here is if I'm
wait, do you agree with that?
No, I don't agree with that. So
Why?
the issue is
you just agreed with it.
No, because if
you just said that one ray, the 91-degree ray.
Listen.
Okay, but you just said the 90-degree ray goes along the surface of the building. We were comfortable with that, and it dies out. The 91-degree ray, the bottom one's going to hit the ground first before the top one.
I'll tell you what degree of the top one is going to hit this fictional observer?
I don't know. My only point is the concentration. It's higher likelihood, the top one over the bottom one, always. That's my point.
Depends on
those other things depend on the channel. You know, the actual specifics of what we're seeing.
So wait a minute. So let's say the observer is X number of meters away.
Okay.
Give me the degree of the top point that is going to reach the observer.
It's the bottom one plus some percent. It's always more than the bottom one. That's my point.
No. So give me the degrees that. Oh, give me 3 potential degrees of the top one that's going to hit the observer at X distance. I don't care what distance. I don't care what degrees, but just give me 3 degrees that are next to each other. You know, perceptually of what might be the case.
We could just draw them. We could just assume no channel and draw straight lines, and I could tell you exactly.
So 91, 92, 93, let's say.
Sure.
Okay, so now that means that 89, 90, let's say 88, 89 and 90 of the bottom one are also going to hit.
Okay.
That's all that is. Now,
no, 1 second. The point I was making is, let's say the ones at the top, let's say 91, 92, and 93 hit. There's never going to be more than that from the bottom, right? Just geometrically. Do you agree with that? It can never be the case.
No, if there's a cone of 3, then a cone of 3 from the bottom one is also going to hit.
No, but it can never be more. It always has to be less than or equal to, right? That's my point.
Equal to, there'll be 3,
less
and
than
like
or
I
equal
said, so
less than or equal to.
Equal to.
And this is 1 second. Let me finish my final point. So this is the difference between ballers, is that they can't admit things that are just obvious, you know, and they have to stick to the fact that the top.
Tell me.
1 second, let me finish my point. This is for the audience.
Tell me what degrees.
Yeah, this is for the audience. This is where we can't really debate these people, because I just proved that the top will always be more visible by using a very simple Muppet vision example. But you have to stick to your guns that the top and bottom will be illuminated equally, but that's not true.
My God, educate me then. Which degrees are going to reach the observer at the bottom, and which degrees are going to reach the observer at the top, whereby the ones at the top are more?
It's always statistically and mathematically.
Give me a band of 3. Give me a band of 3, and I'll draw
a simple example. But I just want you to get the concept first. You're struggling even.
No, I get your hypothesis. I just say it's patently wrong.
It's not.
So what I'm wanting to do,
it's obviously true
to you. Obviously to you.
No, it's obviously true.
So just give me the 3 degrees of the top one that are going to hit the observer, and then tell me why 3 degrees of the bottom one will not. It's only 1 or 2.
Because they may hit the ground before it reaches the observer. That's the whole point.
Some will hit the ground, except the ones that are flying towards the observer will not, and there will be a spread of 3 of them.
Right. So do you agree that if the 89-degree one makes it from the bottom, it's obviously going to make it at the top? That's my whole point. Any ray that makes it from the bottom one,
it doesn't matter. The top one will too. That's the whole. This is where we know you guys are lying. Please tell me a situation where less of the bottom in these degrees, and give me the numbers, won't make it, but the ones at the top will.
You already know this. I think you're just trolling. The top one, the rays will not hit the ground as fast as the bottom one. That's the whole point.
It's not about the ground. It's about straight line to the observer here. I don't give a shit about the ground.
But we're talking about the angles that may not make it. So some of them at the bottom, the cluster.
I don't care about the light that doesn't make it to my eye. Only the one that does, or into my camera lens. Now tell me why there is less of them at the bottom than there is at the top, please.
Right, because the top, that angle, that all those rays, they already have sort of a quote advantage. They are not going to be close to the Earth to get absorbed by the Earth. And so there'll always be a preference for rays leaving the top and the bottom.
Quote unquote advantage and a preference. These are just speculative.
No, terms. Based on the angle.
Please can I help?
Yeah, like just gonna do.
Hey, listen, on, guys. I'm gonna run, man. I'm gonna shoot out. It's Rude Earth, mate.
Okay, Rude.
I'm gonna hit the hay, guys. It's been great. Cheers and everything. Mr. Gervais, thanks for all your bullshit and everything. It's been a spectacular display. Thank you, Ricky. Peace out, y'all.
See you later, Rude. Listen, I'm going to do this. Hold on. I'm just going to do a quick shout out to Plain Truth, who says, let Gleem in. $4.99 super chat. Thank you very much. So, yeah, you wanted in there, Gleem. You got something to say?
Okay.
I did like your orthographic thing, by the way, Gleem.
Let me just share screen and just try and put it in a visual. And I'm not going to play it, Ranty, because I don't want to get obviously struck, because this is the Action Lab. If anyone wants to go and see it, it's called Crazy Material That Can Make Your Home, or You Can Make It Home, sorry, that bends light. And it's just this Mick West thing, you know, with the sugar soap. Yeah. Mm-hmm. So what I think he's saying is that when this goes through, as I say, I'll try not to play it, but if you go up in height, the further you go up, it stays straighter. And then if you come down lower, it bends and hits the floor. You see it?
Correct. Mm-hmm. And just do that experiment 360 times at the top and the bottom, and you'll see that the top will always have a bigger, stronger, tighter cluster of rays.
There we go. It's perfectly done there. He does it to a millimeter there. So,
Dean, are you pretending to not understand this, or do you actually not understand this? Because you're smarter than this.
You're right. I am smarter than this.
So why are you struggling with the fact that a 360-degree emanating light from the top point will always have?
Why are you struggling?
All of those rays making it in the bottom. Always.
Why are you struggling with, if you set up this example whereby you did this with the laser and you were able to pick out, it won't be 360, it'd be 180 obviously, but it'd be 180 minus 2, but you know, at the top point of this experiment, photograph it so that you've got 1 degree all the way through to 179 at the top, and then do the same at the bottom, 1 degree all the way through to 179, and overlay those photographs together, and then explain your concept, because you absolutely will not be able to.
We're not getting there yet. We're not at the channel and the observer. We're talking about just rays leaving the top and the bottom. And I know why you don't want to admit this.
179 leave each.
Can I help again? Can I help again? And
I want to see your orthographic thing, by the way, Gleem, before I go. And I have got to go because it's bloody late for us.
But this guy shows it perfectly. He shows a ball bearing. Okay. He'll lower his camera. And you see the bottom? It's squelching because the top rays are getting to us, so much so that it's bending the top ray to be at the bottom of this jar so you can actually see it below eye level. You see the top bit there? So it's bent the ray for the top part of the object to reach the end bit, but not the bottom or the middle bit. It's cut it off just like you would see the sunset.
Right. There's always a preference.
Right, okay, 2 points. 1 point is, yes, compression is a thing. No one denies that. It is a form of, it's a result of refraction. And 2, when you get lower than the plane that you're looking across, absolutely you will have a sunset.
But do you see here as well? The tank is, he actually makes a highlight of it and points it out now. It adds curvature where there is absolutely no physical curvature in the tank. There we go.
Both of your explanations don't apply to this. So
and then it shows the magnifying as well of this back. Do you see the tiling? You see how it's all perfectly nicely tiled? Everyone's seen these tiles. See how they all squash up and compress just on this one line?
Yeah. Refraction, compression is a thing. We see this in real life.
Now, just to get back, and I don't really want to spend any time on it at all, but
yeah, that's right.
Yeah, this is completely wrong. And a lot of globe earthers say, yeah, if you had a 1 foot wave, you couldn't hide anything but 1 foot. And this would be what they're representing, which is wrong, I'd say. This is like a perspective ortho mashup. But this is what happens if you've got an object, let's say, if you're 2 meters, that's 1 meter. This is 1.25, whatever, or something. And this is 1.8288, whatever 6 foot is. Yeah, so up here, you would see, obviously, an overlapping effect occur. Now, what actually happens is exactly when you said you've got the bigger object, which is 2 of these, then this bit would actually, or let's say half of it, would compress quicker going towards the horizon if you had them side by side. Let's say they were a meter apart. You had a 2-block one.
Uniform scaling due to perspective is never biased towards the top or the bottom. The simple thing is it gets twice the distance, half the size. It doesn't say twice the distance and the bottom disappears.
Okay. So what about those starlight images done last night?
The point is there's...
I haven't actually seen them yet, Ranty.
Yeah, there's an uneven distribution. So this would be perfectly fine if it was 2. Yeah, because your center line of sight is dead center of the object, so it would evenly disappear, like if you pushed a 1 meter cube out into the horizon and it was dead at your eye level, all you would see it is squashed down. You wouldn't see it in 3D. Put it that way.
Can I ask a question about this diagram?
Well, before you do that, I just want to ask Gleem. Somebody's in the chat asking it's Racky Your Life asking if you actually have a link for that video. So if you've got that link, you could drop it into me or into the chat, whichever.
Yep, it's coming into the chat right now, and also oh, did that stop sharing? Yeah, sorry.
Dean, you're shady, man. I don't like what you did to me today. Very rude.
Oh, sorry. What did I do?
Playing dumb. You're not like a blonde ditz.
Oh, I'm not playing dumb. Jesus Christ. Sorry, not Jesus Christ.
Yeah, you are, buddy. I asked you what caused the apparent junction of the sky and ground, and then
I said, well, the apparent junction.
Yeah, the definition of horizon, the apparent junction of sky and ground. You claimed it was Earth curve. You're totally being a doofus.
No, I said it was physical.
Now, if I could just really finish it off, just with this quickly, I just want to show you 2 additional effects. But one, I want to ask you a question. Did you ever come on the scene when there was a big old fuss about Nathan Oakley making stuff disappear from the floor, bottom up, in such a short scale? And loads of people added loads of videos in, and you could see stuff. And even Jose done it on a supermarket floor.
Yeah,
I've seen Jose's. I have seen Jose's. I haven't seen that.
Dean, you've seen mine too. Curvy carpets.
Can I ask you for your exact reason for that happening? It's an overlapping effect, isn't it? Similar to this, but the actual objects are disappearing behind whatever is in front, and that's what I'm trying to get from you.
Right. So wait a minute. So here's a statement that you guys will love. Refraction can hide something. Now, when I say hide something,
I'm trying not to talk about refraction at all.
No. So listen though.
Yeah.
Because this has been who is it? Sleeping Warrior's done this as well, or showed me a video of it anyway. And it was in a warehouse, and refraction erased. Well, it doesn't erase. Obviously, it's bending light, but it erases the bottom of an object. But I could still see the top. But the bottom of it was, it bends light so that it's basically invisible almost. Oh, not almost, was.
Yeah, and that works on a flat Earth and curved Earth.
Yeah. That's just light and refraction.
But not so much on a supermarket floor.
Right. So wait a minute. And everybody always talks about this, shit disappearing from the bottom up. Yeah. That's not the amazing thing about determining the geometry. The fact is, the object translates downwards when it should only ever converge to your eye line due to perspective.
That means nothing.
And that's the key. That's the killer. So my question here to you, Gleem, is object C. Let's say we got 1 degree is object C, yeah? And then we've got another object above it. We'll call it object D. The same size, and let's call it another color, blue. And that's 1 degree, yeah? Correct?
Yeah. I mean, you can go wherever you want to go, but
so wait a minute. Moving those away, is there ever a situation where object C will get to be a different angular size to object D if they both move backwards away from the observer uniformly?
Put it this way: if you moved everything back, the green one would eventually cover both of them.
No. Forget the green and yellow. I'm just saying we're on about an object now going away in perspective. Is there any way to hide just that object? I know we can put objects in front of other
I was trying to explain that. I was trying to explain that exact thing. And what I was trying to get you to say is that it's a bumpy floor. And then what I was going to try and to get you to say after that is, please can you show me the most perfectest flat sea or the perfectest flat floor looking across any land, any of Miles Davis photos, any of these Mount Rainier. I want to see somewhere where it's perfectly flat, not this 16,000 drop in Mount Rainier of the actual topology of the land. Is there anywhere which is perfectly flat like this land here now? Or is it more like a supermarket floor with little bumps that you could just hide something behind as long as perspective allows the acute angle?
Perspective is not the reason. The floor having a non-uniform shape. The floor's non-uniform everywhere.
Exactly.
I don't know of. If you ask me, I suppose
Gleem, just to fast forward this a bit. Just to fast forward this bit. Everything I just went through with him, he will not concede that the angle of the top matters in visibility. They won't do it. They're not allowed to say that, and we understand more now. 1 second, let me finish. They can't say that, even though it's obvious. I came from the light ray angle, you're coming from the bottom up thing, which people have done tests. Life is short, as I would say, proven it. They're literally not allowed to make that statement, because then that doesn't mean that the earth is flat, but then that would mean that objects can be obstructed, and always is a better statement, always obstructed bottom first all the time. And they're not allowed to make that statement.
Wait a minute, man of God, what do you mean not allowed? I don't get that. Not allowed by who?
You're only allowed to say equal to, and I just needed you to say less than or equal to, but you're not allowed to.
No. But I mean, not allowed implies something is restricting me, and authority is restricting me.
I know who that is.
Okay, please tell me.
Satan
is doing this to me, right?
No, okay. I know exactly who it is.
Oh my God,
admitted this. No, you admitted this, and I've got to actually ask you a question on a personal level. And I don't mind you, Dean. You're actually sound. Right. You're actually good to talk to, my man. But you admitted you were a Mossad agent. No, I'm joking. Xbox Connect. Xbox Connect, though. Remember, we were talking about that on Jose's the other day.
Oh that's not bullshit. Yep. We had an Israeli. It was an Israeli optic device in our R&D studio for ages. We did not know that later on that would become Xbox Connect.
Yeah, but I mean, what happened? I listened to it back either way, trying to get. You come into the conversation, and it's not actually your fault because the conversation went everywhere. But you come in saying, you just explained about how your mate, or this is what I did explain, you and your mate got a Connect, and we decided to actually program it or try to program it using Eclipse. And using that, we couldn't actually get a full lock on because there was a distance perception, and it was rubbish at that. You could actually find an object, but you couldn't get any depth, and you come straight in saying you just spoke a load of absolute.
And I'll tell you why. Sorry, I should have qualified it.
Yeah, I didn't.
I do apologize. I should have said more. When you're using Eclipse as an IDE and whatever programming language you want, and you're doing it through a third party, you don't have access to the hardware drivers and the actual API and libraries for the Kinect. Those libraries published by Microsoft.
It was $5,000. So we had to use. It was a public preview. That's what it was from Microsoft themselves, but they didn't give you the full drivers. I know.
We were able to track things. I'll tell you another thing. I made the world's most racist game as well because of a color problem that didn't detect people.
I know that exact thing.
Man, you guys are.
I know that was a terrible mistake.
That was to do with perspective, though. This whole conversation.
All my dirty laundry coming out now, but no. So the APIs that were on the Xbox Kinect and the things like the kinematic tracking and all that kind of stuff were the best for the day, and it could track. I think we got on average probably about a centimeter and a half, but we can just interpolate and use inference on the kinematic skeleton to track like players or objects or things like that. So we could tween in between it quite easily to get pretty much imperceptible accuracy.
Yeah, I get that now. I'm sorry for interrupting. It was one of them things that just sprung in my mind. I was I need to just ask you what.
Now, Gleem, that if we ever have a conversation, we can have a conversation. It's when everybody else.
Exactly what you just said there, because it was spot on. It was perfectly spot on.
But Gleem, can we confirm that Dean is a Mossad agent? Is that
no, that's what I was adding it for. It had to distract it from that, and I just had to get my answer in because, he was right. He was right, but I wasn't chatting shit. I don't think, because we did have difficulty with it unless we would have bought that $5,000 actual developer pack. Yeah.
Appreciate your honesty, Dean. That's.
I'm not a Mossad agent. I take it. Mossad is like the Iranian special forces or something. This wasn't the military, by the way. I thought it was at first. I thought it was a missile tracking system that reading some of the documents.
I thought you said Israeli defense. Or something like that.
No, it was an Israeli optic tracking firm. It might have been used for defense, but that wasn't in the documentation or anything that we got.
So, Dean, why don't you give glory to the creator, man, and let us just be honest that the top will always have optical preference to be viewed than the bottom on any surface because of the argument I just made.
Because you can't demonstrate a mechanism for it. Just because you want it to be the case does not make it the case.
No, strictly density of light rays emanating from the points.
The density of the points, if we say they are from 1 to 179, they all leave. Yep. And if we say that a cone of a degree is always going to hit the user, we can work out each one of those cones from each of those positions based on an observer, and those cones will intersect at the observer. It is that simple.
But more of them will always be on the top. That's my point. And you actually brought this point up as to rewind this whole thing. And so you brought this upon yourself, but it worries me that you will not concede a very, very obvious geometric statement and statistical statement that I'm making. The reason I bring up the reason I bring up statistics is that we are dealing with light rays, and then like from the sun, I'm talking about in real life. So we don't have to invoke statistics if we assume those 170 or 180 light rays like you're talking about. So you get my point? Those 170 leaving the top, more of them will always reach an observer than the bottom. They could be equal. Fair enough if you're close enough. I get that point. Right next to the building.
Or if you're far away.
If you're far away, the top will always have a preference.
No.
Always.
The top preference, no. The top or the bottom does not have a preference. The only preference is mathematics, and mathematics dictates that if there are straight lines to the bottom, you would be able to see it. And that's it.
The bottom has the ground that's going to interfere.
The ground does not interfere with it. If that were the case, you'd be able to have the same argument on a corridor, saying that
you don't think some of those rays, some of those 170. The whole point is that if you think of the top, this actually sort of summarized the whole argument. the exposure of that top point is, like you said, 180 degrees, right? The only thing that's missing is the building itself. So you have 390 quadrants, right? The bottom does not have that many quadrants. Do you get that argument? Just simplify it. That point is exposed to 180 degrees, right? How many is the bottom?
The only light rays that are relevant are the ones heading to the observer.
Dean, I know what you're doing, and I don't respect this, dude. But I respect the fact that you have to troll.
No. You don't care about the light rays that headed down to the ground from the top, or the ones at the bottom that headed down.
Can I ask Dean a question?
Is the lines that are going towards the observer, and you have to demonstrate.
Let me ask FED. Do you at least understand my point?
It won't be about your point.
I was in and out of listening to you. Sorry,
okay,
man.
Sorry, that's fine. Go ahead. Sorry, my bad.
So, Dean, if I was facing north, looking at just facing north, and the sun, the sun was to rise from the east, come to my zenith, and settle in the west, would you say that it would make a path of a triangle in the way perspective works?
Would I say it would make the path of a triangle in the sky?
Due to the way perspective works. In other words, if I was facing north,
no.
If I was facing north and I saw it rise to me, would it rise? Would it come to me in an angle and then rise to my zenith?
It wouldn't make a triangle, no.
So it wouldn't make a triangle.
No.
So why does the sun follow the path of perspective?
Perspective has got nothing to do with the path. I don't know what you're on about. Path of perspective.
Well, when objects move away from you that are above the center focal point position, they appear to move downward into the center focal point position. This appears to be a geometric constant based on angles.
Yeah, there is a convergence point, correct? Yes, that's not a triangle.
So yeah, but I'm just saying the path of the sun. If we were to face north, you would see the sun rise. It doesn't rise in a curve. It rises in a like you can make a triangle of it. Have you not looked at your own vision when it rises and sets? You can make a triangle from the zenith position to where it sets.
Oh, sorry. Oh, you mean you don't care about it in between? I thought you meant it somehow travels in straight lines. You're just on about taking the points where it rises and sets at either side, and then there's zenith, and that's it, and drawing lines between them. Then yes, that would, depending on your latitude.
Well, if I was to match my perspective, I'd be able to work it out so my perspective would draw the path of the sun would work out to be in an angle, in a shape of a triangle, right? If I was to draw a perspective, correct?
You're losing me here again now.
So if I was to emulate reality, and I was to draw reality. If I was to emulate reality by drawing my perspective, right? I would draw.
Dean, is it past your bedtime or like?
It really is actually. Do you know what time it is?
Why doesn't Satan provide us with some mentally sharp ballers? Where are they?
Because it's nearly 2 a.m.
Like people who understand unique solutions, rigor, exhaustive solutions. Search
6 a.m.
Multivariables.
So I am not at my most alert right now.
Oh my God! Like, what's Satan's number? Like, include him and get him in this call.
616.
Jeez, why can't we talk to smart people? It's frustrating.
Cheers, mighty God. Thanks a lot.
But either way, both of those points.
I wanted to get Dean to ask me why the sun follows the path of perspective. If we were to draw perspective, it would rise in a triangle at zenith, at the point, at the peak, and then set, drawing a perfect triangle based on my vision. So my question was, what are the odds that the Earth is rotating in the path of, in the way that it shows path and perspective of straight angles, or straight lines, pardon me?
Yeah, but the sun doesn't go in straight lines from where I am. I don't know where you are.
So if I was to draw perspective, it would be. You wouldn't draw any curve. You would draw straight angles, and you would draw a triangle. If you were to take the observer's perspective of the path of the sun between rising and its zenith and setting, you would draw a perfect triangle. There would be no curve to it.
My question. Wait a minute. Do we agree that the path of the sun in the sky? There's something weird going on. The path of the sun in the sky is an arc through the sky, depending on your, and that arc is the magnitude of the arc is based on your latitude.
You wouldn't draw that in perspective, Dean. You wouldn't.
I have drawn that. Well, I have got a model with that.
Would you? I would love to see your model of.
It's 0.3 degrees.
I would love to see your model in the path of the sun based on our vision of perspective. That would be amazing.
I can do that for you, but some other time. I'm really tired at the moment. So yes.
Does anybody
Dean,
find
stop lying?
But can I ask a question of flat Earth data on the sun for 2 seconds? Do you agree with the following statement that the sun rises and sets due to perspective?
I believe that the physical idea of what the sun is only apparent, so it's all optics. Yes.
So so yes, you agree that the apparent sun rises and sets due to perspective, correct?
Due to optics, yes.
Optics, and the main mechanism for that is perspective.
No, he's saying there's more variables than just that.
Okay, so tell me what they are then. Tell me what the variables are.
Well, why do you always want us to dumb things down to you and not say it
tell me what the variables
a lot of different things? The actual substance, what it is, the physical thing.
The variables are many things: the apparent location, the aperture of our eye, and the refractive index of the lens of the eye. So there's many. There's humidity in the air. Just
really quickly, let's just stick to one. So refractive index of the lens, let's say we use a camera lens. Can you now tell me the mechanism by which the refractive index would perturbate the apparent position and or the perspective calculation of where the fuck the sun is?
Okay, so you're asking me to take an optical lens of a camera and not talk about our human eye, when the human eye is what I was talking about? You want to change the subject and talk about an optical lens now?
Well, the problem. So here's the problem, and I should have mentioned this earlier. The human eye, we don't necessarily have the same vision, nor do we have the same interpretation of what our eyes see. So me describing my vision to you is absolute fucking bullshit, and yours to me, absolute bullshit. What's easier is we both use the same fucking camera and the same lens. That's why when doing these kinds of observations, to have a relative standpoint, we don't just talk to each other, we take photos.
Yeah, but let's talk about our standard vision and what we see optically. That's what I'm interested in, because the apparent junction of the sky and ground is what the observer sees. You take a zoom-in camera, you're going to take a zoom-in camera, you're now going to compress the angles, your angled view, by zooming in on the object. And what's going to happen is, based on the height of the camera that's being zoomed in, you're still going to be limited to angles of light.
Right. So now we're to the camera. Can you tell me how the index of refraction of the lens or the accumulated lens elements perturbs the apparent position by mechanism of perspective or index of refraction, please?
Well, the refractive index is where the light bends into the lens, correct? That would be relative to the size of the lens, maybe the thickness of the lens.
So, the field of view of the lens encompasses the view of what we're looking at.
The bottom line is that it's an apparent junction of the sky and ground. It's an optical effect. You, when asked, claimed it to be a physical effect because it's physical Earth curve. And the same breath that you admitting its physical Earth curve, you admit to the angular size change of the clouds as it moves away from the observer. You deny the refractive. What is the refractive index due to a camera, to its sensor? What does it do?
That would depend on the lens element itself.
Yeah, what does it do though? What is the what happens to your image based on the refractive index of a lens? What happens to it?
It depends what lens and what lens group.
What happens to the fucking image when the refractive index is in the equation? What happens to the image? Doesn't matter what the fucking refractive index is. What happens to the image?
Do you know how a lens works?
What happens to the image based on the refractive index? Who gives a fuck how thick it is? What happens to the image based on the refractive index?
You know that it doesn't contain one element.
What the fuck happens to the image?
Do you know there's 19 Commonly, there's 19 fucking lens elements with dielectric coatings, convex and concave.
Oh my God!
Hold on. We're getting feedback here. Getting feedback. That's coming from you there, Dean. Right, go ahead,
It's
guys.
almost bedtime for Dean.
Can I just answer that again with some with an image, so everyone can actually see some. And it may be a bit out there, but it's a NASA citation. But anyway, first to start with, it wasn't NASA. It was the dolly zoom effect. I don't know whether anyone knows of this. It's been used in many films.
Yes.
But it's a distant zoom effect.
Yeah.
And if you can see, the angular size of these changes, but the blocks don't in proportion. So
wait a minute. Very importantly, that is only because the focal length change exactly matches the distance to cancel out angular size. I've done this many times. Yes.
Yeah. Now, everyone's aware of the moon illusion. What's your common rebuttal / reason for the moon illusion, Dean?
I don't know what the moon illusion is. Scroll up.
Okay. Sometimes you see the moon look about 20% bigger on the horizon. It's a perceptual error rather than
It's a cognitive thing because I've thought that sometimes.
Yeah.
Well, it's only a relative comparison to an object that you can see near it.
Yeah, the normal answer, I mean, bear in mind this is NASA. The normal answer is the Ponzo illusion, where you've got two lines and they're the exact same, and it's just with perspective they will look different. Yeah.
Well, however, it's not actually just with perspective they will look different. It's with objects.
It's a reference
forming that geometry. Yes.
Yeah, if I can just read this out. Some researchers believe that the moon illusion is the Ponzo illusion, with trees and houses playing the role of the Ponzo's converging lines. Foreground objects trick your brain into thinking the moon is bigger than it really is. But there is a problem. Airline pilots flying at very high altitudes sometimes experience the moon illusion too, without any objects in the foreground. What tricks their eye? Now, this is very important. Maybe it's the shape of the sky. Humans perceive the sky as a flattened dome. With the zenith nearby, and obviously the horizon far away. And this is a perspective effect or a cognitive effect. You're exactly right. However, not saying it is exactly, this is the reason, but if you can imagine the distance is going, you've got reference objects around you in the similar thing where it can be countering the shrinkage with this mirror effect, even though our eyes don't zoom. I fully understand that. And then obviously you have NASA basically saying it's a flattened dome effect. What more?
Yeah. So you guys still need to come up with a why the moon or the sun break perspective if they are small and local.
Dean, chill out, man. It's the same argument as life is short, except it's a higher, further object. It's the same principle, man. Like, you need to watch his videos and debunk it, but you can't because you guys suck at math or you pretend to suck at math. But
so diffraction is the key.
It would apply that similar thing would obviously scale.
So can you show me the chromatic aberration that is a clear indication of the waveform separation?
Why don't you
due to aperture refraction
confirm reality before you get into all that? You don't even
okay. My God, listen to this. My God, listen to this. My God,
why would we talk about all that other stuff?
Just thought experiment. Let's say we don't know how far away the sun is or the moon. Let's say the sun, correct? And you do know that if we see with a solar filter, we can see an actual definitive object and no glare. We see this circle.
Are you measuring it? Are you measuring it based on the understanding of your optics, or are you measuring on a presupposition you live on a ball?
Exactly. Both are important.
I'm measuring it as in it's a fucking circle in the sky, and I can see surface detail.
So hold on. What are you counting for?
So wait a minute.
Are you counting for? Are you counting for optics? Let me carry this on.
Let me carry on this example. Yeah.
Are you counting for optics?
Yes, I've got a solar filter on it, and I'm playing dead straight up.
What are you claiming the sun is when you account for optics?
A big fucking light in the sky that's got surface detail, and it's a circle.
Awesome.
Well, you don't know that.
So now, I'm just describing to you what I see with a solar filter. If I looked up at the sky not right now because it's fucking 2 a.m. in the morning. I see a circle, I see surface detail if I'm zooming in, and I've cut out all the glare, and that's it. There it is. So my question to you is, I do not need to know how far away this object is. All I need to know is if it's at its zenith above me, it's 1 unit away. That's all. 1 unit.
What the hell are you talking about,
man?
No, you don't know anything because you don't acknowledge that objects that have height have a preference to the base.
That's all they call it. That unit could be anything. It could be 3,000 miles.
Why would I listen to you when you don't even acknowledge things on a local level that are obvious?
How many units would that have to travel away from me to get to 60 degrees in my vision? It would have to travel 2 sun units away.
Dean, no one cares what you're talking about.
Now,
literally,
with 2 sun units away,
listen, dude.
No one cares, dude.
We would expect half the size.
Great.
To get down at the last degree of my vision, it would have to travel 69 sun units away, which increases in size every time it doubles the distance.
What are you doing? Are you quantifying an apparent object? Are you quantifying apparent angular size? What are you doing? What are you talking about?
No one.
Oh.
So Dean, what if you took the arc tan?
You can have denial all you want, but that's reality. 616.
No, 666.
I've been told it's 616, and if I'm sent by Satan, you should believe me or whatever.
You went on this long diatribe of nonsense when you do not acknowledge the obvious fact that life is short, as proven, and we all know now. Objects can indeed be obstructed and do always get obstructed first bottom up just because of for many different
just only where we expect the Earth curve. Yeah, I got it. Yeah.
So why
Hey Dean, I got a question for you.
Oh God, you've got nothing but questions for me. And I am really fucking tired now, so this is better. This is the last question because I'm gonna have to go. Although you're not saying anything. You might be on mute.
The only question I have is, why are you here? Well, who do you work for? Who pays you?
Oh, no, it's gone. Who pays me?
Who's your employer?
We established that. Mossad, come on.
My employer is a enterprise software development firm.
Do you work for Rumpus? Because he says he's in software as well.
No,
how do you know Rumpus?
I do not work for Rumpus at all.
Have you met Philip before?
Who, sorry?
Like Rumpus's sidekick?
I've not met Rumpus.
Are you acquainted with him through
any of his associates?
Okay, so you only know Rumpus through these hangouts?
I do indeed. I only know George through these hangouts. I only know you through these hangouts. I only know Gleem through these hangouts.
But you make a living non-ball Earth, flat Earth related. You just come here for kind of educating us, right?
No.
No. What's your motivation then to spend this much time talking to us? If it's not financial.
It's nice to be challenged, and it's a break from me doing what I'm doing
we're
right
stupid,
now.
Dude. We believe the Earth doesn't move, and you know it does. So why would you come and ask us for things? Because we're dumb, right?
No.
Okay, so what have you learned from any of us? Gleem, myself, FED. What new concept maybe have we helped you? You know, you're not allowed to say less than or equal to. I've proven that. So
no.
What have you learned from any of us?
You haven't proven that I can't say words. I'm really sorry. You've just proven that I won't admit to something when I clearly think it's wrong. That's all you've proven there, my God. What did you say? Why am I here?
Mathematically obvious.
What do I get out of being here?
Right.
Tolerance, and acceptance, and.
You're trying to improve your tolerance?
Yes.
Okay, so it's like just for your physiology, like debate skills.
No, not debate. I'm not interested in debate. But when I want to be at the stage, and I think I am now, so I could actually leave this and be absolutely fine. I want to be at the stage where someone is questioning my views that I know to be true.
Yeah.
And they're doing so in an aggressive way, calling me stupid, calling me a fucking retard, calling me sent by Satan, all this kind of stuff. And me.
Don't forget Peckerhead.
Peckerhead. And me not give a shit and not even feel sorry for the people doing it. It's irrelevant to me. And I think I'm there now.
You're trying to develop some thicker skin is what you're saying.
Right. Physiology control is what I like to call it. So how are you doing in that? Has it gotten better? Do you find your
Oh God, yes. Oh my God. Since when? Since a year and a half ago,
Can we give you a report card on that? Can I give you feedback on that, if you don't mind? I would say a majority of people. That's honorable if that's actually the case, which is obviously not. But people who do come in here strictly for the love of the game to improve their debate skills and all that. What we do get though is a lot of people who are irritated when we even hint towards adding other variables, in this whole discussion about the shape of the Earth, people get real angry for some reason. If the Earth is a ball and we add those other variables, guess what would happen to normal people? Those variables would collapse into the true geometry, right? There'd be no issues. If we add 5 other variables into a reality that is truly a ball Earth, guess what would happen in real life if we tested those? They would collapse into the truth, right? But for some reason, we look at other things, not just optics, but other things, other aspects of our reality, and then people get angry, for some strange reason. You're a little bit more level-headed. Rumpus goes crazy. Sean Hawkins is insane. Carla Pagan is just emotional and makes wants to kill us for some reason.
No, he doesn't want to kill you.
Oh, I do. I have a video on my channel. I can play it right now, actually, if you want me to.
If he said he wants to kill you, it's just joking. He can't really want to kill you.
Sorry. Yeah, okay, that's hilarious.
Although, wait a minute. I might correct myself here. I have just watched a series on Netflix called Tiger King or something, and you Americans are afforded way too much wacky ideas sometimes. So,
right. Sorry, I missed the joke. My bad. Sorry, that's Carla Pagan's sense of humor. Okay, sorry. I'm okay with that.
You're not saying Tiger King then,
right? So you see what I mean? For some strange reason, there's a lot of people who actually aren't practicing that type of temperance, and control that you're claiming to come here to try and improve. So why do you think that is? Why do you think other people, again, not you, because you're doing very, very well, get triggered when we try and increase the search space of the variables that are looked at to determine our reality?
I don't think. Well, people get triggered because of maybe 2 primary reasons in this field. One is they are claiming authority of something, and since you're challenging that authority, they need to defend themselves. Or 2, actually, wait a minute, let me think. So you got authority challenge, and then you.
But wait, that's a good point. Why is there even a notion of authority? We're just talking about variables, right? We're talking about, hey, are these buildings moving or not? Why is there even a notion? I'm glad you brought that up. That's an excellent point.
No, because
why is there a notion of authority or 1 second? Why is there even a notion of hierarchies, right? Keep going. Sorry, go for it.
So the authority from this point is kind of like if you're like when Rumpus goes off on one and calls people stupid. I think
on a nice day.
On
a nice day.
I don't think he does more than call people stupid.
No, he's called Paige a bitch. He's called us everything that you could imagine.
But everybody calls everybody everything in this fucking film.
We don't.
It's whether they mean it or not.
I've never called a female
you
that.
You called me a servant of Satan or something.
You are serving Satan if the Earth is flat and stationary. If the Earth is flat and stationary, you are serving Satan. That's a fact. And if the Earth is a ball, I'm serving Satan.
No,
I'm honest about it.
That's
then you would have to go, if you were a Christian, then you'd have to go directly against Job chapter 38, verse 38, chapter 14, or sorry, chapter 38, verse 14. Pardon me. You'd go against. It gives a little description. It tells you what the shape is. So if you are Christian, you would be going against what was written in the Bible. And then so this is just a fundamental thing with anything written in the Bible. If you look at what the scriptures describe, it's a compass. It's enclosed with bounds that keep the water in, and it's in the shape of a seal.
Do you get that, Dean? But Dean, do you understand that? That's
no, I don't get the shape of the seal.
No. He's getting at that. A lot of us are here for the Bible, for God.
So it happens. No, I'm just saying that's not what I'm saying. I'm saying that if you are a Christian and you are contemplating if the Bible doesn't offer a description of the earth, I would say you're wrong, and I would back it up with a scripture.
No, I'm not a Christian.
Which is definitely not a Christian. He's
I know that, but I'm clarifying for Dean. I'm clarifying for Dean if he's not certain the Bible does actually have a literal description of what the shape of the earth is. They call it it's in a shape of a pressed clay seal. Okay, yeah. And then there's many references to a compass, and many references to being inscribed, and many references to the bounds of the ocean, like bars and doors, and a reference to the firmament that he calls a tent, or stretched out above. So there's obviously two inferences there. One is that
the sky, obviously the stars are stretched out across, and that it's something covering us. So there is enough evidence to give literal description. Unfortunately, Dean, I can't launch a rocket. I would if I was a billionaire for sure. But you see, the thing, Dean, correct me if I'm wrong, they already did that in 1948. The richest man of the richest, 60,000 feet in 1948? And then what, now in 2020, space travel is 60,000 feet? Like, there's a lot of bullshit and hard swallowed reality, I think, being a billionaire and having limitations to machinery. Last I checked, diesel vehicles, minus 60. What is Antarctica? Minus 90? They can't go that far. They can't travel certain zones and across. It gets to be minus 90. So tell me how they travel through minus 90. So this is nonsense.
I don't think Dean denies that the Bible supports FE. Do you care, Dean, or even make statements like that?
Okay, I'm going to make a statement now, and I don't give a shit whether you believe me or not. I would love for the Bible to be true, God to be real, and the earth to be flat. Now, I actually mean that. I actually do.
Well, okay, let me ask you a question. Hold on.
Let me finish.
I will. I promise. Just let me interject this one thing. Do you not, as a smart guy, an honest guy, do you not find these observation conversations at 6 feet, 10 feet, 15 feet, trying to calculate drop in such short distances, immediately saying we're really close to the Earth and we can detect curvature, and then you fucking hop in an airplane and you can fly flat forever? Are you telling me that these conversations aren't asinine and benign because you can hop in an airplane and there's no fucking curve, no dip, nothing? It's only calculated for an observer standing on the shore. Are you telling me you're not going to admit that's a fucking weird motherfucking conversation to have?
No, because
so hold on. You're calculating.
Your HUD actually shows you a drop.
No, this is what's happening. You're fucking calculating drop for an observer standing on the ground. You're actually negating angular size change for objects, but you're concluding its curve at fucking 6-foot observer height, 12-foot observer height. But then you get into a plane and it's none of that shit, dude. So you have to understand you're calculating curvature rate away at the rate of what? It definitely is not a 3,959 ball. If you get into a fucking plane, that math is destroyed, dude, because it's at this point.
Let him finish his statement, because I think he was going to concede something light.
I wasn't going to concede. I was going to tell you the reason why.
Well, just to let you know, guys. Just to let you know, guys. I've got 5 more minutes, and then I'm going to be closing shop for tonight. So you guys carry on. Oh, and by the way, a shout out to Amanda Young who says the mind of God is on tonight. You go, the mind of God. Awesome. Thank you for the super chat. Right, carry on, guys.
Ranty actually missed the fire emojis at the end of that. The mind of God is on fire.
Meaning that
with the
God
times, Ranty.
No, I'm just kidding.
He was in flames, mate. He was in flames.
Yeah, exactly.
No. So what I was saying, I would. Well, I don't know whether I'd love the God of the Bible, but I would love there to be a being, an all-seeing being that, is this nurturing, ultimate, all good, and for the world to be flat, and for us to be contained, and him to be looking after us, and for there to be an afterlife, and all of this stuff. And the reason for it is, I'm probably a little bit selfish. I want to know. I want the potential of seeing loved ones again. I want to be able to think that when I face death with people that I care about, that's not the end, and it's not the end for them. But the problem is, I'm also pragmatic. I'm also analytical. Unless there is, just because I want to, I can't believe it. There has to be a damn good reason for me to believe something.
No, fair enough. But one point.
Okay, hold on. Hold on.
You just said,
if you listen, this argument of flat Earth, it comes down to this one thing for me. Okay, how easy it is for me to show people the lie. It takes 5 minutes. I show mainstream videos of them telling people to grab a pair of binoculars, stand on the shore, and there's evidence of curvature. I've seen it through all the big astronomy lessons, everything. Okay. You telling me right now we get into a plane and there's none of that measured dip, only for an observer standing on the ground. You're telling me that's not a lie, Dean?
But wait, FED, let me address his point about the spirituality aspect. Is that, Dean, atheism has literally
I had a point though. Mind of God, I had a point. The point was
he's not getting at the proof for flat Earth.
The point is that's a major lie. Who's propagating that major lie? Well, if the Bible does say it's flat, and you have other people propagating this lie to tell just normal people, grab a pair of binoculars, you'll see the boat go over the edge. It's a lie.
Wait a minute, I've got a question for both of you. It's a religious one.
Cheers for the $5 super chat there, Godzilla. $5 closer to 500. Awesome, mate. Thank you.
Flight of data. If the Earth is a sphere, is the Bible and the God of the Bible completely invalid?
Yes.
No, I know your answer. I'm asking.
So my observable reality shows me, because I've been in aircrafts many times, I've even taken aviation lessons. God shows to me that water is contained and it's stationary and level, and it makes sense. It would be It would be impractical to be a ball, especially when it comes to any.
You missed.
Especially comes with any kind of aviation. Flying over a ball would not
invalidate your understanding and your clinging to the Bible. Would you still cling
if the Earth? If I found out the Earth was a ball, it's not a ball. It's not impossible. It's not even.
But I mean, if let's say
it's not even possible. It's not even possible. That's the thing.
If it were, does it invalidate your interpretation of the Bible? That's my question.
Because it would because what happened was you would have to show me why would they throw the lie out there that boats go over curvature at 3 miles? Why would they throw the lie out there when everybody can hop in an aircraft and there's no fucking curve? And that's just because
he's not even going down that road. Like he doesn't.
It's the lie, dude. It's the lie.
No, it's fair enough. I like it. You know that it's flat, and that's I give you credit.
Yeah, but it's a lie, so I can't reverse that lie. So there's no way I can think that is plausible until I had an answer for the lie. Right. Once the lie is answered, then okay, that's different. But right now, I see it as a blatant, easy lie that I can show anybody. Because anybody who's been in an aircraft, I can show all these mainstream videos of everybody talking about curve, grabbing a pair of binoculars, and there's physical curve. That's not true. That's purely and utterly optical.
But by the way, Dean, your point, you've been so defeated by atheism that everything you said was not selfish and just logical. You know, wanting to see loved ones, wanting to see this narrative tie together, which is all happens in God's mind. That's why I call my channel The Mind of God. Those are not selfish things. Why does optics work if you have an interest in that? Why are you here?
I do think actually wanting to see my loved ones or me wanting something else after death is selfish because it's about me.
No, but that's a logical desire for any of us. Just like food is something that we need to eat. That's not selfish to eat food to stay alive. That's the way we're designed, right?
It's something that I want.
Okay.
Therefore, it's selfish. It's not selfless.
Atheism has killed you, man. Your mind has just been destroyed. Don't hang around Rumpus and George anymore, man. These people are
don't hang around Rumpus and George.
So, can you tell me how it's selfish to want to reconnect? Just out of curiosity, tell me how it's selfish.
Dude, that's brilliant. That's amazing. We all want that.
Well, no, yeah, we all do. And
tell me how it's selfish.
Okay, so imagine. Okay, so imagine I go to a funeral, and I look at people there, and me included, everybody's saying what this person meant to them, what they're going to miss about them, what they brought to their lives, and you start to quickly realize that it's all about them. Yes, it might be the way that individual did something, but every single contextual thing is about the positive that was brought to the person speaking. And most of it is that. Yes, there'll be some anecdotal stories about the person that passed.
But you're portraying a funeral process in your mind.
Right. Carry that on.
What about people that don't have any? What about people who don't have, like, bum on the street that just dies of tuberculosis last week? No funeral. He just gets cremated. Nothing.
Yeah, but
he gets a right. He gets a right to see his family, but I don't think that's selfish at all to want to see your family. I think it's a longing. It's a necessary longing because it wants us to change as an individual. It's part of the lesson that we go through. It actually helps you change to have that longing.
But the difference is, Fed, to you, that's an absolute. To me, it's something that doesn't exist. So for me to want something that doesn't exist and to change my reality to me is a little bit selfish.
It does exist.
To you, it isn't.
It does exist because that's your conundrum. If it didn't, you wouldn't have a conundrum.
Like I say,
Dean, just give glory to God and just tell us what you know, man. You know more than come on here pretending.
Yes,
Ranty's made all these predictions. He's helping us. Why don't you help us, man?
I'll tell you what. I would love to be the person that just opened up and spread all these secrets about, the fact that we're all government agents and all this kind of shit, or I'm a Mossad agent, all that kind of stuff. I would love to do that. but I just can't because it's ridiculous.
Why don't you one day just pull up your bank account, direct deposit, hide the balances, just show us who pays you, and then we won't ask any more questions because money dictates everything, right? So, you know, if you did that, I would tip my hat to you.
You got to admit, Dean. You got to admit, Dean. It is comical to watch all those grown men flock to this movement.
Right.
It depends why they're doing it, Fed. It depends why they're doing it.
No,
what
we
their
want to know
motives
why.
are.
He's asking. We're asking why, in an indirect way.
Well, yeah, but that's going to be different for everybody. Oh well. Okay.
There's some common themes though.
Yeah, no, there's going to be a multitude of things. Some might have correlations, but I can pretty much tell you that, you know, if you pick someone else, their reasons may not be mine. It's not just this one.
Now you want to explore a lot of variables when it comes to this, but earlier you only want to look at one. There's not many variables in this domain why people are doing it. We see some themes.
Don't know.
We're not stupid, man. We know.
There's no way a normal human. One second. There's no way a normal human being would spend 4 or 5 hours, potentially multiple hangouts a day, come on here and have families and stuff, you know, and like need to take care of themselves. Like, there's only 24 hours in a day, right? And it's not exactly like everything's free, like, you know, food falling from the sky, you don't need to work and all that. We know the times, like the way things are. So we need some people retired, maybe bored, all that, but that's not everybody. That's pretty much just George, probably. Mm.
So what's up with all the other ones?
You do have people that come here that they add, you know, they're debaters. They want to verbally jostle, and it is about winning. No, well, it is about winning. So I think Rumpus was a debater, Barney was a debater, Brenda was a debater. You know, these are people that have debated. Well, Barney less so, but Brenda certainly, and you know, there are people that challenge people to debates and shit. And
yeah, who pays them? How do they feed themselves and their family? That's what we want to know.
Well, probably the same way you or Ranty or anybody else does. They'll have jobs and work, I would imagine.
No, we're upfront about people. Like we talk about this on our channels. People know our stories, right? We don't
where do you work, mind of God?
I don't work right now.
Yeah.
I used to work for a drilling company who do not take into account curvy earth when they do lateral drilling. FYI. They don't. So I don't know where this curved earth is coming from, man. No one uses it. Pilots don't use it. Directional drillers don't take it into account. Seismic people don't take it into account. I work for a seismic company. So what's up with this ball earth? Who's using it? Who's using this curvature to do things in real life? Not in your optical program making up different rendering scenarios and stuff. Where is this ball earth? That's what we want to know.
A good thing for you to look into, mind of God, and I'd love your take on it, but like I say, it's very important that you understand that it's open source and you can read it. Is the GPS satellite network? I think that's a fantastic place to start. If you could invalidate the GPS satellite system, I'd be very, very.
You don't think that's strange
interested.
That me as an electrical engineer spent 4 years studying and we never talked about satellites once in 2004? You don't think that's odd for a curriculum to not include that? Very obvious use and proliferation of satellites orbiting ball Earth. You don't think that's strange, Dean?
Depends whether you've got a contextual use for them. But
well, they're everywhere apparently, and they're obviously out in industry. Professor Phil Bell claims that they're doing all this stuff regularly. You don't think that would be a topic that we would discuss as an electrical engineer in our schooling to prepare us for? I
don't see what I actually don't see, and this is me being honest. I don't see what electrical engineering has got to do with satellites versus a pod electric control system on a cruise ship. The two are just electrics. You don't need to contextually bias towards one or another.
No, I'm not saying you study it in every class. You don't think that it would be in one textbook?
I think this subject needs to be done on another day. To be fair, it's getting a bit late here for us guys here in the UK. So I'm going to do final thoughts, guys. So let's start with you, Dean.
Yeah, interesting chat. Like I say, I mean no offence, and luckily, due to what I've the things that I'm getting out of this, I also take no offence. So don't even when people do call me, coming from Satan and all that kind of stuff, it doesn't affect me anymore, which is good for me. But yeah, good show, Ranty, and nice to speak to people.
Cheers, Peckerhead. Gleem.
Yeah, I just want to say cheers. Nice one, Ranty. Nice one, everyone, for a good civil one. I think the people got chopped off who were a bit of troublemakers. They got chucked out of the pub early. Either way, nice one. I'll speak to you soon, no doubt. Peace. One.
Flat F Data.
Thanks again, Ranty. Awesome show. Much appreciated.
No worries. Well, thanks very much, guys. Thanks everyone for stopping by. That'll do for now. Hope you all enjoyed it. Thanks to everyone who supported the show in the super chat, and I'll see you all in the next one.